All right, hello everybody. We're back for episode 6, bonus episode. Not really. Well, kind of. So basically, I have this feature. I released, or I posted like initial beta version in like Discord, and I got some feedback from some people. So we've got a list of things I forgot to do, and other minor improvements that I'd like to work through today. And I got my list right here. So big things are, let's see here. Dum-de-dum-de-dum. Yeah, so we want to add the ability to disable the mounting holes, so you're not required to have a part. So you can just like make the hat. We want to add a fillet to like the concave edge, which is pretty reasonable. Expand the selection options for the legs so you can select like circles and stuff, which I think is reasonable. And then we also want to set properties on the hat itself, so like the name, color it, all that good stuff. So we'll go ahead and do that. So the first thing I'm going to do is I'm going to start with the new UI probably. And I guess the other big thing we want to do is we want to open up the mounting options. But okay, let's do this first. So this, and then I'll also do type.circle. So I want to open this up to allow selecting like circles and things and just make it more general. So definitely circles. I am wondering about cylinders, which would be the whole face itself. I don't think I'm opposed to it. Well, I think part of the problem with cylinders too is it does allow selecting like arcs and things, which could be kind of goofy. I also don't really want to spend a ton of time like adding a bunch of different selection options. I mean, otherwise, type dot, yeah. I mean, I guess let's see. We can test real quick. Let's take a look. Whoa. Did not like that. What did I do? I made a syntax error. Yeah. Oopsie daisies. No? Come on. I committed. Okay, yeah, so one of the fun things with FeatureScripts is syntax errors are not handled well by the error handling code. Okay, let's give this a shot. Oh, I don't actually have a bearing. Oh, it's so sad. I need a arc. Sketch fillet. Yeah. Okay, let's see what we got here. So I can select like an arc, for example, which is a little goofy. I can also select circles, of course. I'm okay with it, I guess. Well, is the code different? Yes, the code is different because one evaluates the curve definition and one evaluates the cylinder. Let me check. Let's see here. Hum-de-dum-de-dum. I don't really want to spend that much time thinking about this too, as I already said. Circles, geometry, yeah. All right, I'm gonna limit it to just circles. I think that's fine. And I mean, technically, like, it isn't really feasible to have a circle without a sketch point anyway, so like people could just select the sketch point and like not be lazy. So it's not a huge deal either. Yeah. Okay, so we'll do that. And then we'll need to support it down here. So if we scroll down, hum-de-dum-de-dum, here's where we get our custom mounting locations. We have a nice query for it. And so here, right, we're just going to add some checks, right? if is query empty context definition dot mounting location q geometry dot circle, right? And we'll do this. Return world to plane, right? Circle plane, and then we're going to do const circle equals evaluate. So it'll be an evaluate function because we have a geometry type, right? We'll do this, right? So curve definition. This will give us a circle. I assume the circle will have a chord system. And then we'll want the origin of that. Oopsies, should be using location here because we're mapping over first mounting location, second mounting location. Let's see here. Yeah, so this will turn a circle line or what have you, which is cool. So yeah, so we'll just guard it with geometry type that circle. That should be reasonably efficacious. And actually now I'm tempted almost to, no, that's fine. I could, yeah, so and then let's make sure a circle looks like what we think it does really quickly as well. Oh, that did not open what I wanted it to. Nope. I want the documentation. I want a circle. Is circle. Okay, yep, it has a chord system and a radius. So, yep, and we just care about the chord system here. So we're very happy with that. Cool. All right, and so we can test it. I will make a sketch point here, or a circle, I guess. Right, so if we select this, ta-da, it works. Okay, cool, very happy with that. Okay, and we did both of those. Yes, I remember copying and pasting it. Yep, all right, cool, not so bad. All right, we'll keep on chug-a-lugging. Oh, I guess we should check. Okay, fine. Actually, no. I was thinking you could check make sure the circle's z-axis is parallel to the plane, because if it's not, that's technically an error. But I'm just going to project it, because if someone's doing that, like, you know, whatever, we'll just create something valid, and then, you know, I would imagine at that point they'll realize they're being goofy, and figure it out on their own. So there's not really a point in going hunting for an error, when you can still produce something valid, and then, you know, they can go from there. So, yeah. Okay, cool. All right, let's see what else we got to do here. Fillet concave edge. Yep. Okay, so this is going to be interesting. So after we've made our hat, right? So we have our bearing hat. We've extruded it. We've cut the holes in it. We've cut the counterbore hole. And this could be a function, actually. It probably should be. I probably just forgot. But yeah, so let's go ahead and check for concave edges, right? So const edges. So we're going to start with a generic query for edges. So let's look at the documentation, right? So basically we want to find all the concave edges, right? And so there should be some queries for that if we scroll through the list of queries down here, right? So the first thing I know is we're probably going to want to find all of the edges owned by the hat, right? And the way we can do that is you can either use if you have a query for it, you could probably do like Q owned by body, right? And that will give, you know, all of the that will give you everything owned by a specific query, right? And you can even do entity type, right? So we can get like all edges owned by our bearing hat, right? And then we can probably filter. So we can probably do like parallel edges. Okay. So const edges equals Q owned by body, right? And then I already have a query for my bearing hat up here that I can just use, right? We want the edges, right? And then I want the edges that are parallel, right? So we'll do Q parallel edges, right? And I'll say they have to be parallel to our circle plane dot normal, right? So if you think about how that works geometrically, it makes sense, right? Context comma edges, right? So those are our edges, right? So we're most of the way there. And then, of course, we just want our one concave edge, right? Not this feature. We just want our concave edge. And so the way we can do that is, let's just search concave. Okay, so there's concave connected faces, tangent connected faces, tangent connected edges, loop edges, parallel edges. No, not very helpful. Q hole faces, fillet faces. No, those are faces. Q intersects line, Q in front of plane, within radius closest to, largest, smallest, split by. Okay, so none of those are particularly helpful, right? So that means you probably are going to have to go into the evaluate functions down here, right? And so the one in particular I'm thinking of is there is evaluate edge convexity, right? And so this returns the convexity of an edge, right? Which is ostensibly what we're doing here, so it kind of makes sense, right? So what I'm going to do, right, is realistically there should only be ever be one, but I'll do it somewhat generically. So we'll evaluate this query, right? Because evaluate edge convexity only takes a single edge at a time, right? If you pass all the edges in at once, I would imagine it would give you the single one, which wouldn't be very helpful. Yeah, no, those are helpful. So we're going to have to map over a query, right? And the way you map over a query is you can evaluate the query to get all of the individual edges, right? And evaluate query, what it does is just takes, because a query is just a generic list of instructions, right? So this is saying everything owned by bearing hat. Bearing hat is itself a query, right? Which is just saying like everything created by this specific ID in this feature, or everything created by this specific ID, right? Get all of the edges it owns, and then get all of the edges of that are parallel to, some vector, right? So this is just a generic object, right? It's just a list of instructions. There's no there's no actual meaning, right? And so what evaluate query does is it takes the context, which in this case is going to be the part studio, right? Or you can think of it as the part studio. It's really just like an Onshape internal object, so there's a bunch of stuff in there. But you can think of it as like whatever you have in your part studio at this very moment, right? And it takes that query, right? And it's going to run that query against that context, right? Or against that part studio, right? So it's going to say, okay, now I have my query and I have my part studio. I'm going to go into my part studio. I'm going to actually loop over it, right? I'm going to evaluate all the things, right? So, it starts with Q created by ID, right? So I'm going to look for anything, all that ID in my part studio, right? And I'm going to find all of its edges and evaluate it, right? And return that as a list of individual queries for the individual edges, right? And the queries themselves, like the subqueries that it returns, right, are now very specific, they're a single element, a single thing always, is just kind of the rule. And they're cached so that way, it's fast lookup, right? So that's what evaluate query does, right? So it just gives you the actual thing. So that's a very technical explanation. Basically what evaluate query does, right, is it turns a query into a list of individual elements, right? Corresponding to things it represents, right? And so because it's a list, right, or an array, you can loop over it. So for const edge in edges, right? Let's see here. We'll say edge array, I guess. Is it of? In? I thought it was in. Oh, is it var edge? Oh, it has to be var. That's funny. Okay. So we'll loop over edges now, right? And then convexity equals evaluate edge convexity, right? And so here we'll take our individual edge, of course, right? And we'll get the convexity, and then if convexity equals convexity edge convexity type dot, and here we want concave, right? Then we are going to I'm just gonna put this in here so I don't have to name it awkwardly. So here it's concave, right? Concave edges equals append concave edges, right? Edge, right? And then if concave edges does not equal empty, right? Now we can do that. Yeah, and this needs to be var, right? So the pattern I'm doing here, right, is I'm iterating over edges, right? For each edge, I'm evaluating the convexity. If the convexity is concave, I'm adding it to some result array, right? And the thing I'll point out, right, is I'm using an array. So I could actually use a query if I wanted to be fancy, right? Edge query, right? I could just start out with like q nothing, right? And instead of using append, I could do this equals q union, right? Concave edge query, right? And then edge, right? And so this would also work, right? And so the difference is that instead of the end, I have a list of individual queries, right? Here I just have a query for all of the edges, right? And so semantically, these are very similar, right? And you might say, well, like if you're gonna like call op fillet, right, which is what we're gonna do down here, right? So we'll call op fillet on our concave edges. And so because this is an array, right, and op fillet entities is a single query, right, we have to convert that array to an entity. And the easiest way to do that is to use Q union, right? Because Q union actually has an overload where it takes an array of subqueries and returns a query for all of them, right? And so you could cut out the middleman by doing it like this, building a query, and then you don't have to call Q union down here. You can just pass this directly, right? So both of those are equivalent, right? So the only, but I'm going to do it using the array and calling Q union once at the end. And the only reason I'm doing that is because calling Q union once at the end is slightly more performant. Because if you think about like having an array and then like calling Q union once, it just iterates over all of them, right? Whereas when you build up a query, one at a time using Q union in a loop, right? It's kind of this nested tree structure, right? Because you have Q union, start or Q nothing, and then Q union, right? And it's like this recursive structure of like lots of Q unions, right? It never gets flattened. So it's just a little less performant. Although in this case, like obviously, like we only ever have one edge. Like this, it literally doesn't matter. And like, like even if it did, even if you're doing like 100, like your performance is, like 2 milliseconds, right? Like, 1,000th of a second, like whatever. So it doesn't really matter. But semantically, that's kind of a standard. And then here we have to pick a radius, which is actually a really good question. I am just going to choose this number because why not? I could expose the fillet radius and let people choose, but the problem is there's not always a fillet, and so it's kind of redundant. So we're just going to do it this way and call that good. And there we go, ta-da, right? So it fillets, and if we do like a standard hat, right, it doesn't fillet it. So very reasonable. And you could even not run this code at all if you don't have a standard hat, which I guess I'll do. And I guess that means I need the other predicate. Well, I guess I can just do if is custom hat. So Okay, cool. Yeah, and so now let's factor these guys out into functions again. Or well, I guess I'm not quite done yet, so I'll keep going. But I do want to factor that out. But yeah, pull up my to-do list again. Okay, fillet concave edges, we did that. Let's see here. Connect legs option, I don't really care. Threaded holes. Okay, we should make properties for the bearing, right? Yeah, so properties, right? So the one trick with, yeah, so we'll just set some basic properties on our bearing hat, right? Const other, okay, so let's see here. So I don't really have a better name for these guys other than like bearing hat 1, bearing hat 2. So that's what I'll do. You know, kind of the same thing as like how like frame, right? We'll create, oh, I guess it just creates parts. That's funny. But yeah, so this is a fun little exercise. Let's see here. So if you don't use the default naming of part 1, part 2, part 3, right, and Onshape just has some like basic logic to iterate over that, what I'm going to do is I'm going to set a basic attribute, right, on each bearing hat. Bearing hat. And what's my standard? I think I do. Okay, yeah, I just do bearing hat attribute. Right, so I like to have my attributes always as constants, just because it makes me feel like they're a little more stable, even if they're not. And let me go check this one actually. Okay, robot. So I do put the robot there. So I'll do that as well. Robot bearing hat attribute, right? And then for the value, it doesn't really matter, so I'll just use an empty array, right? And so basically, right, now I can do this, right? So I can do constant on bearing hats equals q created by q has attribute. Bearing hat attribute, right? And then I can do q query count, right? And that will return the number of queries. Oh, this needs a context. Ugh. Okay, so we can't use the arrow syntax because the context is the first argument. But yeah, so we can do that, right? And then we can set the name off of that, right? So we'll set it on our bearing hat, property type dot name, right? And we'll do bearing hat, right? And then tilde is the append operator, and they'll do num bearing hats, right? And I get the number of bearing hats after setting the attribute, so it starts at 1. If I did this up here, then I would have to add 1 down below. So it doesn't really matter. But yeah, so that will do the, so that will give you bearing hat 1, bearing hat 2, bearing hat 3, which I think is reasonable. I could maybe come up with a better name, but like, I think it's better just to have it be unique anyway, and people can give it a name if they really care. And you know, that way, like, it's at a glance, it shows you, and then like it kind of encourages you to set your own name too, which you should be doing anyway, which I like. Okay, and then we'll do some other properties, and I think I have actually, yeah, I do have a robot properties library. This is just a few set of standard properties. Yeah, black, aluminum. Cool. Oh, did I ever do a 3D print? Did I stop making those plastic? Let's take a look. I thought I have a rubber. Wait, really? Yeah, that's not a released feature. Onyx? Oh, okay, we'll do this. Yeah. Okay, I don't know why I'm not... Oh, wait, I am using it. What am I doing? Okay, it's already here. Okay, so we'll do this, and I will say export const plastic equals this, right? Just so that this way there's some consistency, right? You might say, wow, like this is really goofy. Why are you setting the property like this? And you're right, it is really goofy. And the reason I'm doing it is because, yeah, I'll just leave that as rubber. Is this also black? This might be a dark gray. I forget how I did it. This one does not have robot properties. Okay, so we've gone off the rails a little bit here, as we like to do. Okay, const dark gray equals that. Okay, that seems fine. Yeah, it's a little darker than the black, which is fine. Okay, so yeah, that might even be a light gray. Oh well, whatever. Yeah, so just that way I have a little bit of standardization amongst my features, right? You can kind of see how those constants were defined. It doesn't matter too much. Context, bearing hat, right? Property appearance, and then we'll do our. I'll probably just do black. I think it's probably the easiest thing. And then so that's the appearance, right? And then we'll do the material. Dot material, and this will be our plastic. Okay, right. So just some basic properties, and yeah. So we can go look at the values, right? So this is just a material. And so you might say like, wow, this is really basic. Like what about all the other information? Like aluminum, right? Like if you use like the standard library aluminum, right, there's a ton of properties it sets. So you can use like, you know, if you're doing like simulations and assembly or things, it's all set up for you, right? And the answer is, unfortunately, the Onshape APIs for like properties is really, really basic. And so for material, right, literally your only options are you can give it a name and you can give it a property and you can give it a density, and that's it, right? No weight overrides, right? None of the fancy other properties, like you can't do any of that. And it's kind of disappointing, to be honest. Yeah, you also can't like select like a standard library property in FeatureScript. Like, so there's you can't, you know, like change it to like the aluminum 6061 from the Onshape library, which is really sad. But that's just the way it's coded. You know, maybe someday they'll improve the API, but they haven't yet. And so that's why generally, right, FeatureScript setting properties isn't really something you should do too much, right? So like I like to set the color just because, you know, that way it has a nice color, or, you know, it's not just like the random colors Onshape gives you. And like, you know, bearing hat 1, bearing hat 2, sure, fine, makes sense. But you know, like, you know, like it wouldn't be good to like have a selector in here for like your different types of plastics, or to like have a selector in here for like different colors. Because the other thing too with that, right, is FeatureScript set properties get overridden by the properties down here, right? So for example, if you edit this appearance to be orange, right, that effectively shadows the appearance set by this feature, right? And the only way to get it back is to reset the properties on here. So you have to come in here, or Actually, I don't even know if you can reset. I guess if you reset all. Okay, yeah, so you can't even reset all until you have something else set, but you can see that it reverted back to black, right? So the only way to get it back is to reset all once it's been set by the user. And FeatureScript provides no way of knowing if a material has been overridden or anything like that. Or well, you can, but it's extremely niche. You have to use like editing logic, and then there you can get the property. And the reason for that is because those overrides aren't applied until after the Feature Studio has finished running, right? It's just how it works. And so basically, right, like generally for feature scripts, kind of the standard is you can set intelligent defaults, right? So you can set like a default name and like a default color and a default material, but you by no means should like give the user like access to that. Because the thing is, because properties can get shadowed, right? So if you do something like have like a feature or like a part name option in here, right, where like you can enter a part name, or you have, you know, like select an appearance, right, where you can enter a color, right? You know, that might work for a time, but if the user ever, you know, like selects red in here and then comes out here and edits the appearance and changes it to something else, right, that UI option is no longer going to function, right? Whatever value you select isn't going to have an impact because it's been overridden, and your feature script has no way of detecting that either. And so basically, like, you know, you shouldn't, like, Onshape already has a color picker, right? And this already does like most things you want. Like you can set your custom colors and things, and like people should already be setting their custom colors. So like, you know, it's not worth it basically as a feature author. So like you can set like a basic one, you know, fine, whatever. But and like, you know, for material, right, if you like select like aluminum or plastic, like the aluminum and the plastic you're setting are extremely basic, right? They would be much better off coming down here and, you know, selecting the actual material and getting all the other values here. So that's just, you know, how it is. So yeah. So that's basically the gist of it. So generally for feature scripts, I say like set a default property. Don't give the user any control over properties, because the user control is they can come after the feature is created, they can come here and they can edit it, right? That's how they should be setting properties. Feature scripts aren't really the place to be doing that. So yeah. Okay, hopefully that makes sense. Okay, anyways, so that's my rant about feature script properties. Yeah, so we did that. Okay. One thing, yeah, I used attributes there, right? I kind of glossed over it. But basically attributes, right, they allow you to set properties on, you can set them on any query in a Part Studio, really. And so the really cool thing you can do with them, like Onshape uses them for like holes, right? Like that's how they generate the hole tools and like, and they use them for like sheet metal, and like frame uses attributes and like that, you know, so like that's how they pass like or like attach additional information to parts, and that way they can like pass it to the feature, because the big thing is like any feature script can call get attribute with a given name, and look for attributes, right? And so that allows feature scripts to pass information from between each other, right? And so that can be pretty powerful. Another thing you can do is you can use them to tag entities. So for example, I could, you know, like this bearing hat attribute now identifies, you know, bearing hats as created by the robot bearing hat feature. So in the future, you know, if I wanted to have a feature script that only works on robot bearing hats, right? You know, I can like ask the user to select a part, and I can get the attribute, and if it doesn't have that attribute, I can go, hey, like, hey, this isn't a robot bearing hat. You're trying to pull a fast one on me. You know, get that out of here. I can throw an error, or, you know, handle that however I want. So like I have some features that take advantage of that, like robot belt and robot pulley. The belts and the pulleys set attributes on each other, so that way like the user can like select like a belt face, and that way we can like pull in the pulley teeth because we know how many like, you know, teeth that belt face has, and you know, do the set the pulley size automatically. So things like that are kind of neat. Anyway, okay, so we'll keep cracking along here. let's see here. Yeah, so we don't want to always cut the mounting holes, right? So that's a pretty easy thing to add. We're just going to come down here, and I'll probably do it down here, right? If is custom hat, or is COTS hat, right? Then we're going to add a Boolean parameter, right? Cut holes. Cut holes is Boolean, right? And this will default to true, right? Because Boolean parameters always default to false by default, unless you set a default, of course. By that same token, setting default false for a Boolean parameter is just useless, or you don't need to do it. As you know, it doesn't do anything, because that's already the default. Yeah, so definitely not cut holes, and that will be true. Maybe it should be like cut holes in part or something. Yeah, sure, we'll do that. And then we'll just come down here, right? We always need a scope. Yeah, we always need locations. And so we'll just hum-de-dum-de-dum, right? And so here, like, having a function is helpful, because we just have to, it makes it a lot easier to apply conditions like this. Yeah, I'm scrolling too far. So here, right, we just come down here, right, and very easily, right, if is COTS hat or definition.cut holes, right? Oh, do they have IntelliSense on the? Whoa. Wait, what? Wait, that's sick. They have the autocomplete on the definition now. Wait, that's actually super helpful. Yeah, back in my day, you didn't have any of that. So like Onshape is smart enough to like compute the parameters you have in your feature and pull them in, right? So it will give you autocomplete. And presumably, and I guess it doesn't yell at you if you enter a wrong one. I guess they don't like know for sure certain all the parameters, but that is cool because they do have access to that information statically. So it makes sense that they can do that. Okay, so that's neat. Yeah, so if we're a COTS hat, we're always going to cut the mounting holes. Otherwise, if cut holes is true, we'll also cut them. Yeah, and so like here, having a function, very helpful, right? Because, you know, it's very clear, very easy to see what's happening here, right? We cut the mounting holes, like, you know, it's not that hard. I guess that's a better name, probably. Cut mounting holes in part. We'll say in part 2. And let's see if that's too long. That's too long. Yeah. Yeah. It was kind of funny how... So for the longest time, right, Onshape had a very strict rule about never having feature parameters, or never having parameter options. Where's a good example? It was like one of the newer features. Oh, that's weird. Oh, I guess that's how it works. Okay. Yeah, so like one of the newer features, right? Like, because they're always very strict about having Boolean parameters that you could see the entire, you know, name. Because for the longest time, right, like you couldn't resize the dialogues. And so it's funny because they all of a sudden started releasing features that had Boolean parameters that were overrunning. And it's like, oh, like, what's up with that? You know, like, that's so sad. Like, you know, I thought this was a standard. You know, like, whatever happened to, like, standards, right? Because it looks kind of goofy because, you know, like, you can't see the entire setting. And then, like, you know, like, a month later or, like, 2 months later, they finally, like, release the ability to resize your dialogues. It's like, oh, like, that fixes the problem. I see what they did there. It was kind of funny, just like a little bit of sequencing. But yeah, that feature finally got released. So that was entertaining. Okay, so yeah, so we did that. Let's just verify that that works as we expect, right? So if you don't cut mounting holes, it does that. Yeah, that makes sense. I don't know what I was expecting. No. Oh, and I guess let's verify too, right? If you have a console, you always cut the mounting holes, because otherwise the feature doesn't do anything, and features that don't do anything are kind of cringe. Generally, like, if your feature isn't doing anything, it should just throw an error. Because like usually you just like, or you should be like verifying selections or, you know, doing something. But yeah. Okay, so we did that. Yeah. Okay, so we'll get rid of this. I'll just edit my list real quick. Connect legs option. I'm not gonna worry about that. Actually, you know what? I will do that. Okay, so I'm gonna add an option here for the custom hat called connect legs. Or collect yeah, and this is going to default to false, which is fine. Okay, so basically what this is going to do, right, is as the name implies, if it's true, right, we're going to try drawing a tangent line between these two guys here, as opposed to like going around. So yeah, so we'll try that. And so the way we're going to implement that, right, is when we get our custom, no, mounting locations, no, when we get, nope, oh, it is, oh, that takes me, get, yeah, so when we get our custom mounting locations here, right, nope, we don't get that there, that's funny. Mounting locations, I guess it's create burning hat base. Okay, yeah, so when we get our mounting locations here, right, if definition dot, oh, that's interesting, you lose the IntelliSense when you get into a subfunction, even though it's still named definition, which I guess is necessary, but you gotta do what you gotta do. Definition dot connect mounting locations. Right. So basically the way the routing is set up right now, right, is we start at our center circle, right? Then we go to our first circle, right? Then we go back to the center circle, right? And then wait. Or yeah, so we go center circle to first leg, right? Then we go back to the center circle, right? And then we go to the center circle again. Oh, that's actually wrong. That's funny. So this should actually be center circle, right? And then this shouldn't be here. So this way you go center circle to leg to center circle to leg to center circle again, right? Because this is a loop, so it runs twice. Okay, so I had an extra call in there. I guess it doesn't matter because you go to the center circle to center circle, and I think I have some code in there that will eliminate edges that have like no length. But that is kind of funny that that was an error that I just didn't catch. Oops. Okay, so that's fine. Yeah, so we will instead, yeah, so basically what happens is we don't want the first one of these calls. So instead of, yeah, so we want to go from center circle to leg to center circle, right? So we would need to skip this on the first time around. So we'll do that. So for I, so if definition.connect mounting locations and I equals 0, right? Continue, right? We'll add a comment. Circle. Okay, cool. Ta-da! So we'll do that. Right. And it's wrong. Horribly wrong. Woo. Wait, what? Wait, I lied. Why do I need... Oh, this is adding the circle. Oh, yeah, oops. Wait. Okay, I did not read my own code. That's fine. Like this? Right? Was it still extra? Oh, it might not have been then. Because it would have been circle to... Okay, it would have been leg to circle, leg to center, then to leg, then back to the center. No, you need to go back to the first leg. Oh, which it does do because it's a loop automatically. Okay, so it was right actually. And so, but this is still right. But I don't need this here. I think that makes sense. And it probably makes more sense too, to be honest, to do it like this. Well, let's just see what this is, I guess. I've thoroughly confused myself. Connect them. Oh, that doesn't work. Interesting, interesting, interesting. The plot thickens, the plot thickens. Okay, let's see what we got here. So it should go, oh yeah, so 1 question mark? Let's try that. Okay, that works. Yeah. So that behaves as we expect, although I don't love this logic now. Can we start at the center circle and then go to the first leg and then... I guess you could do like this, right? No, you have to add it in between. Center circle, first leg, back to the center circle, and then back to this. And then you would want to skip it on the second time around. I guess we can do it like this. Okay. We can also do this, right? Center circle to circle, then back to the center circle, then back to the circle, and then we just skip this here. Although I don't like having to invert this check. Because it's more logical to skip it as opposed to like only doing it when we're not connecting the mounting locations, or we are connecting the mounting locations in like I equals 2, right? Like you can see how that logic is more complicated than just like if we're connecting the mounting locations and, you know, then skip it on like some iteration. So yeah, so we'll do it like this, and we'll do it like this. So we go circle to, okay. Mounting location to center. Wait, why can't I skip? Why can't I do this? Why can't I do that? That's a good question. Oh, I guess it's doing... Let's see, because then it would be doing mounting location to mounting location to center? That seems fine. And then we go back to the first mounting location? Why doesn't that work? What's the difference? You go circle to center to circle and then connect across. What is happening? I'm confused. Yeah, because it's a triangle, it shouldn't matter. Unless it's doing the inverse. It might be doing this here, and then... No, but what's that then? That's a tangent connection. This is a tangent connection. It's probably inverting it, huh? do we think? What if I throw this exclamation mark in? Nope, okay. That would have just inverted the direction. I guess you'd have to invert it everywhere. I'm not thrilled. What is happening? Why is this so goofy? I don't know. Maybe I just shouldn't think about it so much. Oh, this skips it on the second. Yes, it skips it on the second iteration, so you get mounting location, then you get the center circle, then you get the mounting location. 1, 2, 3. Wait, does the chirality matter? Hold on. Hold the phone. 1, 2, okay. And so if I invert these, right, so we said do this. Aha, there's the problem. Okay, yeah, so the direction you've selected matters. Although it shouldn't, because this should take care of it. Right, that's the point. Maybe I need to actually calculate the center, I guess. Const center equals... Okay, so I guess that would bring us back to this mode, right? Because we have the overload where it just takes locations. So let's try that and see what happens. Okay, no. Oh boy. 1, 2, okay, and now we'll go 1, 2, and that's wrong, okay. Is counterclockwise... Wait, so if I throw an exclamation point here... Okay, so that does invert the directionality of it. Oh wait, isn't like... Wait, can I just do this? Goes true, and just ignore that? Or false, I guess? No, I don't want speed recognition. Okay, we're getting sidetracked again. I'm forgetting, because I know by default, because there's two ways to draw a tangent line between two circles, basically, right? Okay, that doesn't work either. That's weird. So, because you can, like, so if you have two circles and you're drawing tangent lines, right, you can draw the outside, you can also draw the other side, right? And technically you can also draw across the middle, but that's right out, right? So here we're flipping between this one and this one, right? And normally the determination of that is supposed to be, basically you flip the one you get depending on whether or not you're drawing in a clockwise or counterclockwise fashion. And the way that's computed is you take the center, we just use the centers of the circles for simplicity, right? But you take the average of them, so like the centroid of the plate, right? And then you measure the angle between each pair of holes, right? So if the centroid's about here, right, the angle between here relative and here relative to the centroid would be about 120, right? About 120, about 120, right? And so then you just add those up, and then if it's greater than 0, you're going clockwise. Otherwise, if it's less than 0, you're going counterclockwise, right? And so if you've selected, 1, 2, 3, right, then if you go in order, you're going to have like negative 120, right, negative 120-ish, negative 120-ish, right? So that's like negative 360. And so, for most plates, it's a very, very accurate heuristic. And then, yeah. And so that's what this counterclockwise function does, right? is it returns true if, if the direction is correct. And so, yeah, so this shouldn't matter at all, and it doesn't. Right. So that's not the problem here. The problem is get prev? No. Counterclockwise? Circle to circle, previous incur. Yeah. Right, because counterclockwise is supposed to flip it, basically. Circle that flipped is true? None of them should be flipped. The radius should always be positive. Yeah, because there was like, at one point the way this feature worked is you put in like a negative radius if you want a flip version, and like that was crazy. So it's now an explicit Boolean. Should one of these be flipped? Should they all be flipped? Surely not. Wait. What is happening? I feel like I always end up doing this whenever I try to use this library. That's not fair, but it's, yeah, I don't know. It's always, this is like the great plate drawing conundrum, or the great plate drawing challenge, is things are counterclockwise when they're supposed to be and not when they're not supposed to be. And it's not amazing. Add arc, yeah, that works. Add arc. Where is add arc even? Oh, down here. Counterclockwise, yeah, get mid direction. What the heck? What the heck? What the heck? Connect them. That's 2. If I make that 1. Yeah, that's backwards. Wait, am I supposed to reverse the array? Let's check. If counterclockwise. I might have forgotten about that step. And the way you tell is because it's backwards when you reverse the directions. So 1, 2. We'll do 1, 2. No, it should be backwards in both. What am I doing wrong? Wait, that's mounting circles. I want, yeah, that is right. Mounting circles, yeah. I don't want these flipped, I guess. Man. What did I do wrong? Okay, hang on. Let's add some print lines. Okay, last thing I'm going to try, and then I'm probably going to give up for now. Let's just make sure it's actually reversing. Ooh, lots of errors in the error logic. What shouldn't be happening. Although I am aware of cases where sometimes you do everything right and like the editing logic does not want to cooperate, right? because like this editing logic is very simple, and like we're adding all the necessary guards that we should care about. So like sometimes when you make like you edit imports or things, like, you know, the editing logic just freaks out for a little bit, and that's just a thing that happens, and there's nothing you can really do about it. So you should try not to worry about it too much. That is bleeding over to standard hole, I'm noticing. Is it? To standard hat? I guess it is, right? Oh yeah, because this only applies for is custom hat. Yeah, that's fun. Okay. Yep, those are the fun errors to solve. Okay, so this is true when I do 1, 2. So now if I do 1, 2, it should be false. Ah, it's true. Uh-oh. That's not right. That should not be happening one bit. Not one bit. Compute centroid locations. This is something I tested. Because, yeah, so let's debug. Okay, let's do a little debugging here. Oh boy, debug. Oh yeah, it's so hard because you don't have access to the context in there. So there's not really a way to get the, yeah, okay. Const centroid equals get centroid, compute centroid circles. Okay, and then let's yeah, so the annoying thing about debug is it does not work for 2D points, because they're not 3D, so it doesn't really know how to display them. So you have to make them 3D first, and usually the way you do that is you do like plane to world. So we'll do our circle plane, and then we'll do our centroid. Yeah, and that just takes a plane and a 2D point, and it makes it 3D, which is helpful for debugging. And then I'll also debug, we'll do mounting circles to dot location, because that should be our bearing center. And that's failing, which is strange. Yeah, this takes an array of locations. That's not right. We have not been passing that. Why has this not been crashing out? Next, cur minus centroid. We're doing maps operations? How is that not an error? What? Okay. All right, well, that's fun. Okay, so yeah, so I forgot that it takes locations, not circles. And because I wasn't monitoring the Part Studio, right, I didn't have that, it wasn't highlighting that error for me. And so this is why, kids, you should always monitor your Part Studios. So we'll do that. Nope, I did it again. Robot bearing hat will monitor, right? And so right away, right, it flags it immediately. Ugh, yuck. Yuck. Okay. And this also should have the predicate, I suppose. Because I guess it doesn't transitively get applied. Maybe it does, but you'd have to come in here, I suppose. Okay. So, yeah. Yeah. Okay. So now we know, wait, mounting locations? Oh. Nope, because mounting locations is a 2D array of points, not our circles. Yeah, that's embarrassing. Okay, so const locations equals, so I'm going to use my extract from array of maps again, mounting circles, and I want all of the locations, please. Right. And now we're going to actually get the centroid. location, right? So again, this is just iterating because mounting circles is an array of maps, right? Each map looks like this. So for each map, we're going to get the value of the key location, right? So we're going to create an array that's mounting location, 0 vector, 2 times meter, because that's what the format that takes is. Okay, so there we go. We don't have to reverse it. And now meet is back on the menu, and we'll verify. So we flip this around, and ta-da! It doesn't matter if you select it clockwise or counterclockwise. Okay, so that took a lot longer than it should have. Embarrassing. This is why you set predicates, and this is why you document things, because those types of errors are very easy to make, and they're easy to miss. And I still can't believe Onshape wasn't crashing in that situation. That's crazy. Did they override like minus to work on sets or something, or to like work on maps? I have no idea. Whatever, doesn't matter. Okay, so that took a lot longer than it should have, but it is what it is. Okay, so that connects the legs. Did that now. Yay. Okay, so now I just have one more thing to do. And that is, I want to add threading support, right? And so, yeah. So basically, again, this will be a subset of the standard library options, right? So like, obviously I'm not going to worry about like tapered pipe taps, like what even is that? But yeah, so I do want my fastener fits, right? And then I am going to need this, wait, what? None? Oh. What the heck? Wait, is there a custom parameter? Yeah, so generally as a rule, you can't do custom visibility off of tables like this, because you just can't. You're not allowed to do it. Is kind of the normal standard. Wow, that is the same. But there is actually a way you can do it. So if we open up whole.fs here, right, so if we look at the UI, what's happening, right, it's a little verbose, is v2, init entities, thread standard, has clearance, right? So has clearance here, right, is always hidden Boolean, right? That's at the top of the feature, right? And then we can see has clearance is being used down here for the tap drill diameter, right? And so basically what's happening, right? Because if has clearance is hidden, like how can that be useful at all, right? The answer is editing logic is being used to drive it, right? So what's happening, right, is there's this boomerang technique where the UI up here, right, like the lookup table is down here, has clearances up here, right? And basically what's happening is they're using editing logic, right? So every time the lookup table is changed, right, they're looking at the value of the lookup table, and then they're setting has clearance based on the lookup table, right? And then now that has clearance is up here and it's set correctly, right, they can use, if has clearance down here, right, to drive the visibility of their parameter, right? So there's a fun boomerang technique of using editing logic to drive, to keep the lookup table and has clearance in sync, and then that way they can do conditional visibility, right? And so if you want to do conditional visibility off of your lookup table, right, so based on the values of, what the user selected in the lookup table to hide and show other parameters, right, that's the technique you have to use. And so if you're listening to that and you're thinking, wow, that sounds like a lot of work and really cringe, you're right, it is a lot of work and it is really cringe. And that's why it's not really recommended, right? And I guess the one other thing I'll throw out, it is possible to do that with other parameters as well. So if you really wanted to have a parameter at the bottom of your feature that like controls the condition of visibility something higher up, right? You could do the exact same thing with editing logic, right? Where you use editing logic to synchronize, your your parameter at the bottom with, a hidden parameter at the top, right? And then you do your condition of visibility off the hidden parameter at the top, and so you can cycle through that way, right? However, I'm going to say don't do that, especially because the other fun thing about because the fun limitation of editing logic, and the reason why it's not like the best thing ever that we just use it for everything, is editing logic does not run when a user is configuring your feature and they make a change to the configuration, right? So if there's like an extrude here, right, and they have like the depth parameter configured by like a configuration of the Part Studio, the editing logic will not rerun in response to changes to like the depth, right? And so if you're using editing logic to drive conditional visibility in that way, right? When the user makes changes, via the configuration, like the editing logic is not going to run. So like the parameters won't hide and show properly. They'll still be there because parameters are always there. They just may or not be showing in the UI. But you can imagine how you could get goofy situations where you've set the configuration and a parameter isn't showing up and it's really confusing. And so usually the standard is if you are using a parameter to drive something, you should mark it as unconfigurable using UI hint.unconfigurable. And so for lookup tables, that's already taken care of you automatically because lookup tables are just unconfigurable by default. So that's why it's okay to like do that conditional visibility stuff because Onshape doesn't have to worry about people changing the lookup table when they're not looking. But that is something relevant to pay attention to. Anyway, so that's your UI fun fact of the day. So yeah, so now I'm looking at this, right? So obviously they are doing that to get this to show up so they can support a fastener fit of none. I am not thrilled by that, to say the least. What even is a fastener fit of none? Like, what is that? Let's go take a look. ANZ drill and tap chart. Like, do they even list that on a tap and drill chart? Let's see here. Number 10. I mean, you got your 75%, your 50%. Like, they got a bunch of thread sizes. Like, everyone just uses 24 and 32. Like, I don't know. Yeah, like, these aren't... As far as I'm concerned, the none fit is not a real number, and people don't actually use that. Is that just the minor diameter at that point, or what? I don't know. I can't be bothered. Can I be bothered? Oh, maybe I could just do it just to show you guys how to do it. Okay, I'll just do it. It's not so bad, I guess. So has clearance. Right. Always hidden. Right. Is this really worth it? I guess so. Okay, fine. If has definition that has clearance, right, then you show this. Right, tap drill diameter. The name is gonna be heckin' tap drill diameter, probably. Diameter, right, show expression, sure. Okay, so there's that. And so it will never show up currently because has clearance will always be false, which is fine. And then let's look at whole again. Yeah, so default, they're explicitly setting default to false, even though you don't have to, because as we already talked about, Boolean parameters are always defaulting to false. But I guess it's a little more explicit, so whatever. Probably not worth arguing about. Yeah. Thread standard, sure. Feature name, okay. Feature type name, yeah, okay. So then has clearance, okay, and then we come down here, hum-da-dum-da-dum, hum-da-dum-da-dum. Yeah, there's that. They add a length tolerance, which we're not gonna do, of course, because I actually don't have time for that. I would cry. Maybe not cry, but I would be very sad. Maybe I would cry. I don't know. Okay. Yeah, so has clearance, right? That's like that. Okay, so now we need to update our lookup table, right? So we already have our fit node. So I need a whole type node. Right. Let's see here. What's in the UI? Hum-da-dum. Let's see. So obviously I'm not going to do all the options. So I will do whole type, right? So we'll do clearance or tapped. So let's make that whole type. Payload, this will be clearance, right, and then tapped, right, double check that. Straight tap, number 10, wait, hold on. Yeah, so whole type tapped or clearance, okay, tapped, what did I say, tapped, okay, cool. All right, and then the next layer down is going to be size, nope, tap type not doing, so it'll be threads, so 24 TPI or 32 TPI. Let's do this for now. Oh, there's no thread, okay, fine. Const thread node equals lookup node, right, threads. Okay, I'm gonna pop this over to another tab so I can look at it more quickly, or to my other monitor, because my life is too short, but you get the idea. I'm just looking at the standard library and seeing what parameters are there that I need to copy. Okay, so there's threads per inch. I'll just call it threads, I guess. Per inch, right? And our nodes are going to be and 24 TPI UNC, right? Swap those around. And then the default will be the second entry, so 1, because it's 0 based. Okay, and then this will be the thread node and the, this will be the thread node. And this will be the fit node. Okay, all right, we'll do that. And then our threads, right, so you can see we're getting very exponential very quickly, right? And here we'll do our fits again, right? Our tapped fit node, right? Again, it'll be whole fit, fastener fit, but now we'll have another payload here for none, right? We're gonna need a map, These are all going to need to be maps. So we'll do hole diameter, this, and then I'll also do has clearance, and this will be false here, right? And this technically needs to be the string. Oh no, it should toString correctly, I think. Yeah, so free will be 0.201, right? None close free, right? Yeah, so this will be 0.1495, right? Oh, it's different for 24 and 25. Ugh. That's sad. Oh, okay, so this is where having payloads can be helpful. Yeah, so here, right, I can set, oh, but it depends on the fastener fit as well. Of course it does. Wait, does it? It kind of does. 0.1495. Oh yeah, close free. Okay. Yeah, so it does depend on that, which is sad. None is such a headache. If it wasn't for none, we could move these values up to, well, I guess these values will all be the same. Okay. That's fine, that's fine. Okay. 32 fit node. Right, so it's definitely getting exponential, which is not good, right? And so that's why like doing this for anything more than a couple holes is very impractical, right? Okay, so this is, yeah, so 24 is 0.1495, 0.196, 0.201, right? 32 is 0.159. Yeah, and then 0.196, 0.201. Okay, and then these will all have a clearance. Has clearance is the positive, right? Let's check. Definition not has clearance. Yes, okay. So this will be false, and it will be true for these guys. True, true. Again, if it wasn't for none, we could have has clearance up here, or even like all the way up here, right? But we can't, so we lose. Why does has clearance add the tap? That doesn't make sense, but okay, whatever. Maybe there's some machinist reason why. And then this will be tap drill diameter. Is the second number. And this will be, okay. And that will vary. Slap that in here, right? So for free, oh, is it always? Oh, it's always. Okay, that's nice. If that's the case, and we don't mind having a tap drill diameter there, I could move it up here. I guess it's easy enough that we can just copy paste it. Okay. So we'll copy paste this up here, right? Boop, boop. Right, and here it'll be 0.1495. So like that, and like that. Times inch, times inch. Right, I do wonder if they're actually showing the expression. No, it's just, I mean, it doesn't matter. Inch is an inch. It'll display however it wants. Although actually, if I change the part studio units to to millimeters. Let's have some fun. Oh, okay. Oh, interesting. Yeah, so if I change to millimeters, right, it displays in millimeters, but if I click on it, I get the underlying value, right? Which I think is what that show expression parameter does, right? Because if I enter like 3 inches here, right? Oh, I guess not. Yeah, I don't know. That's kind of curious. I wonder if that's how... Oh, okay, interesting. Yeah, so here, right, you can see the underlying value has been converted to millimeters as well, right? Which is not what we want. Although I don't know if I care. It does make me curious, though, how that works. Or how to do that if I wanted to. Let's see, these are values. This would have to be an expression. Let me see. Okay, let's do a little digging. We'll go on a fun little treasure trip. Copy parameter? No. Logic. Okay, let's look through the edit logic. Okay, is v2, yep. Okay, here we go. So this, right? The value portion of an expression? Let's see here. So you get the standard table that they're using right now. They loop through all of the values in the table, which is interesting. Oh, they're manually working their way through the table. That's fun. And then they get the value. Yeah. This is an old function that they use. Right. It used to be if you modified the table, it would change it to custom, right? Oops. Did not want to end up here. Where am I? Let's go back to whole.fs. Okay. Just thread in depth parameters. Pre-calculated values. I could have sworn there was some function that allowed to be consistent. Yeah, that's fun. Yeah, they store the strings. Major diameter. Lookup table evaluate? Hello. This supports number times units, number divided by number. So this supports mathematical expressions. And it looks like it evaluates them into strings and numbers, which is cute. String to unit. So this is where they get the actual value, right? So it maps like mm to millimeter and like all of the parameters. Oh, this is probably what they use. This is probably what they use inside the features themselves, actually. That's interesting. I was not expecting that. Or it might be a copy of it. I assume they're not actually running FeatureScript. Oh, they could be. I don't know. Okay, what is happening? Yeah, this is why like looking at standard library code can be kind of mind-numbing, right? Sometimes. This is a lookup table. Okay, this is lookup table code. So, which is fun. Entry, view major diameter. Yeah, so they're just setting it, right? Because that's a value with units. Copy tolerance info. Okay, let's try something, I guess. We'll do something experimental. So let's come down to our editing logic. And let's just set hole diameter equals 0.196 inch. Let's see what happens. So we make any change, right? Aha, okay, that is how that works. That's funny. And we're still in, yeah, because we're still in inches. Okay, so that's good to know, right? That's good to know. Is this gonna be really cringe about giving strings? Yes, it is. I'm gonna have to write a quote function probably. Okay. All right, time to go to my string utils library. Okay, so we need a function to quote strings because otherwise they won't have, it'll be like, you know, the values in the code will be like, you know, 12 inch, right? And not like the string literal 12 inches, right? So I'm going to make a function that quotes things real quickly. String is string, right? I don't know why I've never documented these. Okay, and so this is going to return quote, string quote, right? And quote is just the string literal. Okay, we'll go back. Cool. All right. Yeah, so this is gonna need quotes. Okay. So we'll update these to be like that, and then we'll just set them directly. We won't actually, or it should still work the same, I think. Which is nice. So this is just me like being extra for no real reason. Well, I want to. I don't know. 1495. No, I'm just being extra for no reason. But I don't know. I figure it's not too hard to do, ostensibly. What have I gotten myself into now? Okay, so we'll set this like this, and like this, and we'll do it like this, and like this, and like that, right? And we can reuse this. Quote, and quote, and quote 01495, right? Okay, what are you complaining about? Wait. Go away notifications. Has clearance, colon, ID. That'll be the name of the string token it's expecting. Let's see, so if you look at where the errors start here, right, colon, display name, entries, yep. This is a map. That looks okay. Aha, no colon. That would do it. Okay, ta-da. yeah, so you just gotta like work your way through at that point, and try to find your error that way. Okay, so this will be our tap 24 net fit node. This will be our tap 32 fit node. Okay, so this ended up being a lot more work than I hoped it would be. Also, I got off. Okay, we're back here now. So just switching back to 2 monitors. So I can verify I've done everything correctly, right? So we got our fastener fits, we got our threads per inch, we got our hole types, clearance and tapped, and clearance and tapped is the same still. Yep, okay. Cool. Cool. All right, cool. This needs to be a map, probably. And I guess just to make things really easy on myself, I'm going to add the has clearance is false here. So that way there's never any doubt about what needs clearance and what doesn't. Actually, I could add it. Aha, so here's something where my code is helpful. I can add it here. False, right? Because the way this works is key value pairs added at a node in the tree propagate all the way up, right? So every root in this tree will be has clearance false, hole diameter, and then whatever the terminal node is. So that's one of the key benefits of this library, as opposed to just like hard coding all the values yourself. That and like reusability and whatnot. Because like these could be functions and things if I really wanted to be fancy, which I don't. But yeah, so if you're like actually going to generate this, like you would write functions to that return lookup nodes and like write functions that return lookup payloads, and then you could like more statically define all of your information and just iterate over and really quickly generate a huge table. Because like the lookup table that hole.fs uses, right? So wholetables.gen, right? There are, let's see here. Let's see. It's gone up, I know. Yeah, this sucker is 36,000 lines of code, right? And that's because every single node they have is like its own path, right? And so like, it's fair to say they did not generate this by hand, right? They did not write this by hand. This is all, defined using code kind of similar to my FeatureScript code, in some external file. You can see, yeah, they have all the parameters. Oh, interesting. It doesn't actually specify has clearance. Oh, interesting. Yeah, so they're not actually including that value in their table at all, which is funny. How are they getting it then now? Now I'm curious. Always a dangerous question. Has clearance? Oh, here's another one, though. No. Check if has clearance. That's standard. Oh. Well, okay, that's an easy way of doing it, I suppose. They just check whether the fit is not none. That's very reasonable, actually. Maybe I'll do the same thing, actually, then. And I can copy and paste that function. That's probably a little easier than doing all of this. Let's see, what does that function I copied do? We're not going to have v2, of course. Get standard and table? Standard is the active table. Okay. get standard and table. They have such, I don't know, the naming is a little goofy, perhaps. If we assume the table is the lookup value, then that makes sense. I guess they have fit in here, like none and all of that. Fit close. Right, it's really just a different way of putting it. I guess has clearance is a little more semantic, and I've already written it, so I may as well roll with it. Right. But yeah, that is funny. Maybe this should just be fit. Yeah. The other thing is they probably are just looking at the values themselves, right? So you could find, because a lookup table path is just a map of keys and values, right? So the keys, actually that is probably the way to do it, huh? Let's just do that. Okay, I know what they're doing. Okay, so this is where knowing what data structures you're working with can be a little helpful, right? So this is going to save us some time. I didn't realize the calculation is so simple. Actually, maybe not saving us time per se, but I don't know, it'll do something for us maybe. Okay, so I need my bearing hat table gen, right? Okay, so I'll copy paste my tables again, hum-ta-dum-ta-dum, right? Okay, let's see how this worked. Cool, that looks pretty good, right? So you can see the table's getting bigger, right? So yeah, probably glad about that. Whole table is, wait, what do they call it? That's a good question. ANSI whole table X? ANSI whole table? What do I call it? Bearing hat? We'll say definition not whole, but that seems a little vague per se. Okay, lookup table, whole table, definition not whole. Maybe it should be definition not whole path. Let's rename that to that, right? And bearing hat will be bearing hat path, right? And table, and this will be our bore table. And definition.bore will be definition.bore path. Okay. And if you wanted to be the most semantically correct, you could do table.bore path, but life is too short to do all of that. Okay. Tolerant equals, yeah. Okay, get whole table. Yep, definition.whole path. Whole diameter. Dot whole path. Okay. Yeah, okay, so here we have to parse the expression, parse Okay, so that's the code we were looking at, because I did change it to be the string expressions. So where is that code? Look up table. Lookup table path. So I assume these are hidden. No, lookup table evaluate. Okay. Yeah. Wow, tough crowd. Okay. Ta-da, there we go. So there's that part. And I'm going to have to come back to that function later. I'll update my editing logic first. Wow, I really did a number on this stuff. Okay, whole table, whole path. Okay. I guess I probably could have thought about my replacement a little bit more. Yeah, so there we can just do that. Okay. Yeah, that was kind of boneheaded in hindsight, those replacements. I just kind of went for it. Didn't really think through it. Okay, so yeah, so we don't need to validate the expression. Right, and so here, right, if we print line our definition dot whole path, right, so I'm pretty sure if we get rid of this, don't need it, right, so I'm pretty sure, where is my editing logic? Did I commit? I did. Oh, I have to change the whole path for that to run, which would be this guy. So we do have our table now, right? So we can see, right? We got all our fits and stuff. So we're happy about that. Yeah, so the way tables work, right? It's a mapping of keys to values, right? So we have fit, whole type, and threads, right? And so the keys are the names we defined in here, right? And then the values are these strings, right? The things that the users can actually select. And so, right, here we can do definition.has clearance equals values dot definition.whole path dot fit does not equal none, right? So as long as we have, wait, does equal none? Does not equal none. Do I need to check the whole type as well? I think I do. Yeah, I do. Because oopsies, and this should be fit. Oh, that's awkward, actually. I guess I can just change it directly. Whole fit. Okay, it just appears once. Thankfully, so we'll change that. Okay, yeah, so I do need to check that. So I'll just check whole type is tapped as well. It's easy. It is the easiest way to do that. So has clear, boop, boop. Okay. Yeah, so definition. Cool, right, so that's when we'll show the tapped option. And I think their logic might have been simpler because I think they have I think the tapped table and the the standard table might be separate or something in their code. Because you saw like they had a bunch of tables in there. So, okay, well okay, the feature list is bugging out, as it sometimes does in Onshape, which is always a good time. Okay, cool. So yeah, so we got our whole table now, right? And now, right, if I change it to tapped, and I select, okay, I don't see my parameter. That is fun. Let's go take a look. Or if I had to guess, our editing logic is probably erroring out. And I could check, I could check, but I'm lazy. Okay, yeah, so that's that. Oh, yep, there's the error, right? Definition of whole type does not exist, right? Okay, so there's that. Let's just do this. Const path equals definition whole path. Right, just so it's a little less verbose. Okay, and then definition whole diameter equals parse lookup table evaluate values dot whole diameter, right, and definition dot let's see here, tap drill diameter is not equal undefined, right? Then definition tap drill diameter equals lookup table evaluate values dot tap drill diameter, right? And this could of course be genericized into a function, right, where you take tap drill diameter and whole diameter as a value, and then you just check if whole diameter is undefined as well, because you may as well, it doesn't hurt. And you could iterate over like that. But you know, for us, our table is relatively simple still, so we can just check them that way. And so now, right, this should work in theory. Yep. So we can see there, and then we can see we have our options, right? And it is putting the string values in correctly, which we like. So, yay us. Yeah, I can do free, and that's 0.1495, and that's 0.159. So we're very happy with that. And I'm realizing now I am not actually setting whole attributes, so all of this has been for naught, because these are not actually wholes. That's okay. We'll fix that in a second. Well, that does make me sad, actually, because that's not going to be great for performance, but you got to do what you got to do, I guess. Or I say not great for performance. It's fine. It's just a little suboptimal, perhaps. Okay, so yeah, we're just going to have to use the actual Onshape whole feature, which will be annoying, but that's okay. Let's check our whole definition. Const. Okay, I'll write this function again. What is the parameter name? Tap drill diameter. Equals undefined, right? We'll return, I guess. We'll just abort, maybe. I don't know. We'll just return the value. Right. We'll just return whatever's in the parameter, right? Otherwise, we'll do this validation check, right? So here we'll evaluate it. Values.tap drill diameter. And I think I can use this this fancy syntax. So normally, oh no, I don't have to, because keys which are not in a map are just undefined, I'm pretty sure. If I'm wrong, we'll find out very shortly. Yeah, because as long as this is a container, that's okay. If this was maybe not a container, then you would want to use the question mark access, because if this was like potentially like something, you know, like a value or something, or like not always guaranteed to be a map, then calling dot something on something that's not a map is illegal, and so that will just be a runtime crash. And so there's fancy new Java syntax added like 2 weeks ago, stolen from JavaScript, or well, borrowed, I guess, where if you do this, right, this part will get skipped if whatever is in front of this is not map accessible. So if this was like an array or like, you know, 2 times int or something, instead of calling 2 times int dot, you know, whatever and throwing an error, it would just short circuit the entire expression to undefined. But we don't need that here. But yeah, so we'll do that and then we'll evaluate it. Let's do var, I guess. Okay, and then if they're not the same, oh, I guess I can just inline this. Okay. Okay, cool. Right, so then we'll throw that error as well for the tap drill diameter. And I will do that. Okay. Ta-da. This should just return undefined, I think. And this won't always return a value with units. Because I'm thinking if we're calling the whole feature, we'll just want to do that. Okay, let's do a little inspecting. So yeah, I need a dummy feature again. We're going to comment this out. We're going to have a query parameter. This will take face. Right, and then we're going to get attributes. Okay, that gets all the named attributes. So Onshape whole tool uses legacy attributes, as we found out like 3 episodes ago, I think, while we were just looking at the code. Right. So what I'm going to do is I am going to go on a fishing expedition, basically, and see what attributes exactly are set on an Onshape whole feature tool. And the reason I'm going to do that, right, is because I'm debating just trying to set the attributes myself, basically, you know, the good old-fashioned way. And I want to know how realistic that is. I just want to point, please. Thank you. So yeah, so we're gonna go on a little expedition here and see what we got. So I'll just do a standard 32, and we'll do a close hole. Okay, and this will be through all, of course. Okay. Fastener fit will not be applied if there are fewer than 2 parts per hole. What? Wait, did I just debate myself? Because I don't understand how holes work? Tap through all. Yeah. 2 parts per hole. Wait. What? Wait a minute. Is this doing what I think it's doing? Is this forcing blind and last behavior? Wait, that's so silly. I assume it's not using this, right? I assume it's using the free fit, and if you choose none, you just get a blind hole. This is just a blind hole. Okay, so basically I wasted a massive amount of time because the only part that matters is this part. Oh, I guess this would be the diameter on the mounting hole still. So that part is unchanged, fine. But they're saying basically it starts with a clearance hole, and then if once it goes through the second part, then you start talking about actual fits. That's so goofy, you know? That's kind of wild. Okay, let's extrude this. So let's go ahead and do what they want, make 2 parts. All right. I'll go ahead and select that too to make them happy. Okay. All right, yeah, so that's what happens, which is kind of wild. Because if I wanted to do a single part, can I just do the tapped hole? Oh, I guess so, right? This is the tapped hole, so this is 0.159. Okay, yeah, so they just made blind and last the default without telling anybody. That's kind of wild. I did not realize they did that. Yeah, I don't know. I guess that's neat. Is that neat? I don't know. I thought it was confusing. I guess it kind of makes sense, maybe. I don't know. Whatever. Okay, let's see what attributes we got. We'll do this, and we'll pull up the console. All right. So there's a couple places that could be setting attributes. There's none there. So they could be setting it on the start and ending edges, right? Let's make sure we're actually getting Shift P. Okay, let's make sure we're actually getting the right entities here. Okay, so nothing there, right? Bunch of stuff there. We'll come back to that. And then nothing here and nothing on these faces. Okay, so they're just setting it on the cylindrical face, basically. Good to know, good to know, right? So let's take a look at what values we got. Right. So there's an attribute, there's using the new hole pipeline or the old one. That's all legacy stuff. End type through, hole diameter, hole feature count, hole number, hole feature count. Okay, hole number, hole type, is clearance and tapped, is tapered pipe, is tapped hole, yes, is tapped through, yes. Major diameter, partial through, section face. Right. So all of this stuff is pretty standard, right? Right, and there's a tolerances map. So you could just make it yourself. Attribute ID is interesting, but I assume it doesn't matter too much, right? But this is what causes this to show up in the whole tag, right? In the whole table. So if you don't do this, it won't show up in the whole table. Otherwise, you can just use the Onshape standard library hole feature. Do I care enough? I guess we're in for a penny, in for a pound. Right. The other thing that's annoying, though, is we don't have a way of telling. What's the point of having a fit that's none? Oh, is that saying... Is the whole fit.none for if you're not doing the fit at all, because you're just... Yeah, because fastener fit you just don't need. Right. So like all that has clearance stuff just doesn't matter. Because if you're choosing a tapped hole, you're doing a clearance hole and then you're tapping the plate. Oh man, that's so annoying. That's so upsetting. Although, okay, so it's not all a waste, because you will still have the clearance. And the nice thing is they have paved a path to have that, because the clearance you have is different from the fit. But that being said, we can get rid of these. Yeah, you do have different fits based on 24 and 25, so it's actually not too big of a deal. So we just get rid of that, basically. And then, yeah, so I've decided, I'm thinking I don't think it's worth it to do all of the standard hole feature stuff, right? This basically guarantees this will exist if we're actually checking. Okay, so that can always return our values units, which is nice. Scroll down here. Okay, so basically we don't need the has clearance parameter because it's always going to be true. It's so sad. Actually, do we? Oh, we do. We do still need it. We do still need it. We do still need it. And the reason we still need it is because we're not doing conditional visibility off the table. So yeah. Okay, let's back up the bus here. So this should only be called if has clearance is true. Yeah, so I assume that's the other parameter they have up top, right? Is they have one for if it's tapped or not. Let's take a look. Right. Parse pitch. Yeah. Yeah, so they have the feature name, and then they have the thread standard, and then they have clearance. And the thread standard is, well, that's ANSI or UNO. ISO, we don't care about that, I guess. Oh boy. This has become quite the adventure we've gotten ourselves into. I suppose I'm also not looking at the absolute latest and greatest in FeatureScript technology because my standard library is just not up to date, which is a little unfortunate. But this is because this is the SCD. Okay, so there's thread standard, and then unset ANSI ISO, has clearance, unit system, hole style. Those are just parameters. Inch metric. Unset show thread class. There's thread class. Yeah, there's some hidden parameters they show. Or that's that. Definition of has clearance is the only thing used here? Really? Okay, so they're just using has clearance a lot, basically. I like how it's just oppositely named. Has clearance causes tap drill diameter to appear. Which I guess makes sense because they're thinking about it in the context of like, if it's a tapped hole, then we'll set has clearance to true to show the tapped. Unless the clearance is actually none. Anyway. Okay, so basically what happens is this becomes this. Which is neat. Oh boy. Okay. Yeah, so I'm not going to make the hat holes standard, but I will do the tap holes because that matters. So I guess when we cut the holes, it'll always be like that. And then the other thing I'm realizing now, this is so bad. So the problem with disabling cutting the mounting holes is it only makes sense if you have a clearance. Right. Because if this is, or if you're not cutting the mounting holes, there's no point in having a tap value. Which is embarrassing. Because you don't want people thinking you're tapping these holes or something for some goofy reason. Goodness. This is so bad. At least this makes logical sense, right? Clearance, yeah, and then tapped. Boof. Yeah, is there a less verbose name I could have for this? Connect mounting locations. I guess you just drag it out and it's fine. Okay. Yeah, that's not fun. I'm not having a good time. Now I'm debating just pulling the plug on the entire thing and just not supporting tapped holes. That's really what I should have done, right? Like if you want a tapped hole, just make it yourself using the hole tool, right? Like it's not that hard. And most users shouldn't be making tapped holes anyway. But now it's like in for a penny, in for a pound. Yeah, so if I didn't want to have cutting in the mounting holes, I could move it up here, and then I would basically have to go back to the old style of table where you don't have the hole type, if you're not cutting the mounting holes, because it shouldn't be an option, would be how I would probably want to do it, which is awful, of course. Alright, while I think about that, I'm going to make a create bearing hat function. I'll put it up here. Context is context, ID is ID, definition is map, circle plane is plane, border values is map, mounting locations is array. Okay. Right, and this is going to return a query for the bearing hat. Return bearing hat. Right. I'll factor this out. We'll call it function set bearing hat properties. Right. context is context, bearing hat is query. That's all we need. That's nice, right? Okay. I'll grab this. Function fillet bearing hat, fillet convex edges. Convex, concave. Context is context. I'm going to write this function a little more generically, actually. ID is ID. Body is query. Plane is plane. Right. Because I do think there's actually utility elsewhere. Although obviously I'm not like exporting this or like putting it in a library right now. But you know, I think it's a useful feature. I might use it again later. So yeah, so just, you know, name the parameters a little more generically, right? But that doesn't affect our calling code or anything like that, right? This is an important distinction to realize. Mounting holes. Oh yes, we need that. Is query, right? ID plus fillet, right? Body is going to be bearing hat, of course, and then circle plane, right? This could even be direction. No, it's fine. Yeah, it could be. Vector. Right, is that what this takes? Yep. Takes a direction. Right. Circle plane dot normal. Right, so just lifting up the dependencies, because if you don't need an entire plane, why force it? Right, you can just take a direction. So that's just like standard compositional programming. And I'm going to throw this in a try loop. In a try, because you know, if the fillet fails for some reason, I don't want to throw a big fuss about it. And I could even, I could raise an error or something, right? I mean, probably the edge case would be like if your points are really close together, like the fillet could end up being too big, you know, and it just doesn't work. You know, if you're like drawing something really sharp, I can't imagine that happening. And you know, I think it's better just to like show it and like, you know, obviously the user's doing something goofy. If they see the hat, they're gonna realize immediately that they're being silly. So yeah, not gonna worry about that. Okay, and then we'll make a bearing hat. Context ID plus bearing hat, right? Definition, mounting holes, circle plane, bore values, mounting locations, right? So we don't have to update any of the names because we haven't renamed any of the parameters. Yeah. So that's good. Okay, let's see what we got here. So I don't need this. Well, okay, what are we doing? So, oh boy. We're really in it, aren't we? The problem is I spent all that time making the table now, right? And like I have the table, it's done, it's written, it exists, right? So I feel legally obligated to hook it up. But then we have the don't model the holes problem too to solve, right? I'm also realizing this is cooked for the COTS case because in the COTS case there is no hole diameter. Okay. All right, it's cooked, it's cooked, it's cooked. We can't support it because of, yeah, the COTS case is the dagger here. If we didn't have the COTS case, we'd be okay, probably. But because we do, right, that would mean, so realistically, if we were to actually do this, right, we would need, so there would be a whole table for the COTS case, which is just your standard clearance, or that would just be your standard fit, right? And then for your standard hat, right, you could have clearance or tapped, right? And then for your custom hat, depending on whether or not you're adding, or for these guys, it would be depending on whether or not you're adding the mounting holes, right? You either have your clearance and tapped or your standard. Oh, I guess you have to, okay, oh, all right. You know what, I take it back. It's not actually that bad. But it is annoying. Okay, so this is just our clearance hole table, right? And so this is just going to be our fit node. Okay. Okay, so this is where like having the lookup tables is nice because I can just generate 2 lookup tables like that very easily, which is convenient. Okay, and then we remove the none options. Yes. Okay, cool. All right. It's a little cooked, but we'll make it work. A little cooked. Yeah, that's funny. Okay, so yep. So this is our simple table, and this is the one that has clearance versus tapped. Wow, I've really done a thing. Okay, so this comes up here. Right, and then we need to do our board table. Okay, so that's just reorganizing the UI. Okay. If I hadn't already made the lookup table, I think I would just do the clearance whole table and just call it a night. But in for a penny, in for a pound. We've come so far. Just can't possibly change now. Okay, so we need to do if is COTS hat, right? Or it's not a COTS hat, and we are not cutting the mounting holes, right? Okay, so here, right, and conditionals like this are why like this is so much fun, because you need to check that you're in this branch before you check whether you need to cut mounting holes. Technically you don't, I think, right? Like, I think the logic is still technically correct if you get rid of this, but for readability, I think it's important to have that. So this will be our whole table, clearance whole path, because every parameter has to be unique, right? So you can't just have like whole path. And then this will be our clearance whole table, okay. All right, let's go write the editing logic now. Oh, so cooked. Okay. So here, I need a predicate. I can't. Yeah. Okay, so here we're going to do this. Right. And I'm pretty sure, let me check actually. So predicates are a list of statements, right? Okay, so I'm pretty sure the way this works is, yeah, so I wrote a little UI predicate to tell if we're using a clearance hole table, right? Is clearance hole. And yeah, so you're not allowed to nest predicates because the standard parser can't handle it. So instead you have to inline the logic like this. And if that's, yeah, and so that's one of the major downsides of predicates, is you do have to do that, which is definitely annoying, but you gotta do what you gotta do. And here, right, predicates evaluate in order, and so if as soon as any, so this is basically an and, basically, because it will only return true if both of these are true. And that's actually not the logic we want. So I have to do it like this, actually, now that I think about it. Yeah, because a predicate only passes if every statement within it is true. So we'll do that. Do I like this naming? Sure. Yeah. Is clearance hole. That's fine. It's not the best name, but it'll work. Okay, so we'll do that, right? And then we'll just have has clearance, because we'll set has clearance automatically. Or we'll keep that up to date. So okay, and now there's a bunch of things that can change our whole table, because if a parameter changes, like if they change like from like standard to COTS, right, that could change what whole table you're using and affect whether you're showing the clearance parameter. So it's easier probably to do this. So we'll do that. And oh, let's just return definition. So we'll just to avoid the case where the editing logic fails, because on feature initial creation, all definitions of the empty map, right? So a lot of these operations will fail. And is it always going to be consistent on initial load? It's possible it could have a clearance on initial load, which is annoying. So we can't actually just return out. I guess we could. Definition.has clearance equals is clearance hole definition at this point. Or the whole type is tapped. Oh, that's so annoying. Okay. Yeah, so we're just not going to guard this, basically. And we're just going to have to be careful that the whole type is correct, which I think is fine here. So okay, const table equals is clearance hole definition question mark, clearance hole table question mark. Okay, so this is the point of their get table and path function, right? So we'll return table is going to be clearance, whole table, path is going to be definition dot whole path, right? Otherwise we're going to return whole table definition dot whole path, right? Okay. And path definition. I'm realizing is clearance whole is not an acceptable name because it's really not true. Let's do show use clearance table. Because if you're showing the tap table, you could still be a clearance hole because that has the clearance or tapped option in it. So yeah, so that's a little more meaningful. Okay, we'll go down here. Okay, so yep, get table and path. Oh, I guess we could return the value. Okay, we'll do that, and then we'll return, and then we'll have the value as well. Table, path. Okay. Cool, so that'll be that, and then equals, need a comma there. Let's see here. Definition that has clearance will be true when it is use clearance table and table and path dot whole type equals tapped. Okay. And I'm thinking we don't actually need the table ever. So we'll just do path and value. I don't know if I like this naming, but I don't know. I'm just reorganizing a little bit, I guess, for no real reason. Okay, value is also kind of an awful name. All right, there we go. So that sets all of the relevant parameters. This is actually a case where I could do this. Lookup info.path is always guaranteed to exist. So you could just do this. This works as well, right? Because undefined equals tapped is false, right? So it doesn't matter if the table doesn't have holes, then it'll just not show up, right? So this should be consistent now. If we cut the mounting holes, we get the fit. Yeah, we get the hole type if you are cutting the mounting holes, otherwise you don't. And our code is complaining, I'm noticing, which is not what you want. Oh, right. Okay. All right. Yeah. So this should work. Yeah. Yeah. Okay, and if you do that, you get a through hole. And if you cut mounting holes, then you can make them clearance or tapped if you want. Okay, that's good. I'm gonna make the default there. Did I not? I thought I did. Oh, maybe it's saving it, I guess. Let's see here. Oh, there's a bug. It's not actually setting the default correctly. Oh, that's not good. And we'll have to regenerate that. Okay, let's go on a bug hunting expedition. Here we go. It's not using the default parameter correctly when it's generating the lookup nodes. Okay. If lookup node default does not equal 0, print line default get default name. Is that even the syntax? Ugh. Oh boy. Yeah, it is default. Okay, get default. Why is this not running? If lookup node default does not equal 0. Key default name, index equals lookup node dot default, entry equals lookup node entries, index return entry dot name. Yup, that's right. Oh, come on. Okay, so if lookup node dot default is not undefined, is this right? Merge maps, definition, default 0, definition, yes. What the heck? Print lookup node. Oh, didn't they? Yeah, they did. Okay. Yeah, println used to not support. Used to always require a string, so you couldn't just printline a line. You had to call it with an empty string. That's a new addition, or a recent addition. Why the hell is this not working? Yeah, so right here, this should do it, right? If lookup node default is not equal 0, print line default, get default name. Right, and here I'm using the bracket syntax everywhere because default is a reserved keyword. Right. And so you can still have keys of a map that are reserved keywords, but you have to use the bracket access and pass a string literal because the string literal does not get flagged by the Onshape checker. So yeah, I guess the way I'm doing this, it's never defined, but I guess we don't need that. Greater than 0, I guess. Let's try that. Hey, there we go. What did I change? What did I do? I'm actually kind of confused. And definitely a little concerned. Also, that was not all of my tables. Oh, hello. Next is lookup node. Oh boy. Oh, yeah, can be lookup. No. That's right. Lookup node, yeah, lookup payloads have nodes. What the? Ugh. Silly syntax errors. Thread node. Entries, lookup payload, tap 24. Those are lookup nodes with payloads that are valid. Oh god. What is happening? Ugh. Can be lookup node or string or undefined. Why can next be a string? I guess I was taking advantage of that earlier. Oh, is it because... No, it's just any map. That's not the problem here. Yeah, values map, that's fine. What the hell? Unless I'm getting the wrong... It's possible I'm getting the wrong constructor here because I'm like doing it dynamically and seeing values map because it's not like getting annotated correctly. Even though like it should be getting type annotated, but you know, lookup resolution can be hazy sometimes maybe. Because like a lookup node is technically a map, so like the order, you know, overload resolution is not 100% on always. Also, like, what is... Some of these are kind of goofy. Like setting next to a string. Not sure what that's about. If I'm being completely honest. Maybe I'll just get rid of this overload for now and say next cannot be a string. And get rid of this one too, I guess. Let's see here. These are all my 2 argument ones. I guess name with an empty value is kind of pointless. Don't need that. Oh boy. We are struggling. This should not... What is happening? Value, next. Next is next. Value is value. Next is undefined there. That's fine. All of that is fine. As lookup node. Yes, yes, yes. Ugh. What is happening? Entries, entries, entries. Lookup payload. Oh, here we go. Ugh. Okay. I updated it there, but I forgot to update it up here because this is the actual type definition, and this is just the parameters for the constructor. And so here they're basically the same. Yuck. Okay, yikes. Alright. There we go. That took longer than it should have. And I don't even know... I'm still not entirely sure why the values weren't printing. Or why the defaults weren't printing. They are printing now, right? Yeah, default. I don't know. I I'm not sure exactly what was going on there. Okay, so this should work now. All right, so you get that, and then if you don't want mounting holes, you don't get that, or if you want a COTS hat, you don't get that, or if you do want mounting holes, oh, what? Oh boy. Wait, was I hinging on custom hat, not COTS hat? No. So right here, right, so here, oh yeah, right, so then there, yeah, so we're not cutting mounting holes, so we don't have that, and then if we do cut mounting holes, we do get that. Okay, so that's right, basically. Yeah, that's fine. Okay, so that's right. Okay, cool. All right, so we're going to OP extrude the bearing hat. All right, because it's late and I am tired. So if definition.use clearance, right, then we need to, yeah, we can't just do this. Ugh, that's so sad. Okay, fine. Okay, so we need to map over mounting locations. Map array, mounting locations. We don't need to disambiguate, which is nice. New sketch on plane, context ID plus whole sketch, circle plane, right, const first point equals sk point, right, sketch, zero, right, 1, these don't even return anything meaningful. sk solve sketch const locations equals, okay. You type that vertex, and I think usually you have to put another filter on here, because when you solve a sketch, it turns all of the point references into like bodies, so you have bodies and edges, and it's kind of weird. So the way we can tell for sure is if we debug, right? Yeah, okay, so we just got our 2 vertices, so that works. Okay, yeah, so there's our locations. Okay, and then, okay, so const whole definition equals, so here, right, so we're literally about to call the Onshape whole feature, right? So all of the parameters are the same, right? And then we're not going to worry about setting like the standard and things, because it should just use what we set. But yeah, so locations, right, we'll do locations, right, hole diameter will be our hole diameter. And this will be undefined, right? Every key which isn't in a map is undefined by default. So setting a value of a key in a map to undefined is equivalent to removing it from the map. Actually, I think it does just delete it out. I'm not actually, yeah. It might still be in there, but like it, for all intents and purposes, there's no way to differentiate, or it may as well not be there, right? Because the behavior is equivalent to if it wasn't there in the first place at all. So yeah. Has clearance, that's right. Really? Oh, yeah. Okay, so now we're going to, and then scope, and our scope will be our scope. Oh, I'm doing this in the wrong spot. Oh, that's sad. It's not that sad, actually, but it's a little annoying. Okay, so that doesn't actually go there. It goes down here in our cut mounting holes, right? And there's a point here as well. Yeah, let's just query for a sketch region. God. Okay, we'll do this. That should be stable, I think, probably. Okay, this will return a map, right? Okay, so here we'll pass mounting holes dot faces, and then here. We'll pass mounting holes dot locations. And I'll move this to be before circle plane for, so that way they line up or whatever. Okay, so we don't need this here. And we don't need the hole. Oh, it's such nice error handling too. That's so sad. I could not call the whole feature if we're not doing clearance. I guess I'll do that actually. Problem is I have mounting locations, and there's also mounting circles, and then now there's mounting hole faces. It's a lot. And now there's mounting holes, dot locations. So there's a lot, which is not ideal. So that part definitely hurts a little bit. And I could do like sketch points or something, but the problem is like the Onshape hole parameter is named mounting hole locations. So like locations is pretty usually a query, but the problem is it's not always a query. Because up here I'm using mounting locations as an array of those points, of 2D points, which I, in hindsight, should not have done, but you know, it's too late now. So, well, it's not too late, but I'm lazy. Yeah. Yeesh, it's a lot of places. Yeah, okay. Let's see here. I wanted to use the same workflow for both because that way if you switch from standard to clearance, your holes don't break. Yeah, so we do need to do that, probably. I mean, we don't have to, but like we should. Technically we don't need the plane anymore because the queries have their own direction. So at least that's nice. At least there's that. We don't need to compute the length. We can, yeah, I think we can, okay, there is some benefit to using the whole feature. It will give us error handling and things like that for free, which is nice. Okay, let's just call it. Right, so I'm pretty sure I can do this. Whole context. This will be whole definition. A plus holes. And here, right, I think this ID needs to be the top level, but don't quote me on that. Surely this is used somewhere else. Yeah, it is, because, okay. Right, because normally it's used there. This is so scuffed. Oh boy, so scuffed, so scuffed, so scuffed. Hole diameter is value with units. Okay. Right, so in theory, cut mounting holes will give us the top level error handling. If we pass this ID, we'll test that in a second here. Aha, it does work. Wow, okay. Yeah, so if I do this, right, right, so the top level ID, right, the ID you get your feature is kind of sacred, also in a way, because that's what a lot of the error handling has to attach to. right? That's a lot of regen errors. That's funny. So oh, wait, what? Oh, is it because I'm using mounting holes already? Okay. Yeah, I was trying to reuse an ID. Okay, yeah, so we get funny error handling courtesy of the whole feature. And the depth is not through all by default for some reason. And I wonder if I need to be using all the isv2 stuff. Let's see here. Probably? What does isv2 default to? Also, I just realized the whole table.fs, that is literally the whole table that's being used to generate the whole table, and therefore by extension the drawing attributes. So that is the source code for that. So, you know, the more you know. Is v2, yeah, so is v2 defaults to true. Actually, that's not the authoritative source of truth. So there's this funny, yeah, so this map here, right, this is the, oh, interesting. Yeah, so these are the default values when you call a feature through code, right? So these are the defaults we're using, or we're getting, right? So I'm actually going to set isv2 to true because I'm cool like that. Actually, I don't care, and it shouldn't matter. Actually, I will set isv2 because I want new handling. Because why not, right? And so here, right, we probably need end style. Whole end style dot through, right? There's our scope. Oh, what's the unit system and stuff? Okay, fine. Fine, we won't. Okay, so there, yeah, we're getting none of the holes intersected apart, so it's doing that handling correctly. Some selections not produce holes, that's cool. Right, so we actually are getting some pretty neat handling here, right? Like this I did not have implemented, you know, and so you can disable that and close and free. And that is not coming from me. Is it? How could it be? No, okay, I never updated that code. Okay. definition dot value dot tap drill diameter lookup table evaluate, right? Okay, yay, very fun. Okay, so yeah. Oh yeah, and so the function I used, right, call subfeature and process status, right? This feature here, it's for calling subfeatures. It's just a thin wrapper around process subfeature status, which is the other way I talked about of propagating, whole information, right? And so it's just a wrapper around process subfeature status. So it calls a function, and then with the given context and arguments, right? And then does some error handling to propagate the errors up. So that's basically that's all that does basically. Nothing too, or very very useful if you know how to use it properly. But yeah, so it's taking advantage of the fact that, like the top level ID, you pass that in there, and suddenly you get all of the sub handling of whatever function you're calling. So here, because we're just wrapping around whole, we're able to take advantage of that and get some pretty neat behavior, which is cool. So we can do this and close and free, and it's saying, if we're actually cutting the mounting holes, right? Like we get one of them but not the other, and that's okay, right? Or it does the custom handling for us, which is actually really nice low key. I do appreciate that. And then, so if we look at our configuration panel, right? So we see our hole there. Obviously we could try to get this one as well if we wanted to be extra fancy. But because you don't always have to cut the whole, you could. You definitely could. You would just sketch. Could you change the starting location? You could start on face, although you'd have to choose like this face explicitly, because there's no like default bearing location. I don't know. Let me just make sure. I don't think it matters. I don't care enough. My life is too short, I think, is where I'm at this point in time. And this way, like, the error display is for the mounting holes you're cutting explicitly and not the bearing hat holes, because the bearing hat holes are obviously going to be correct. So I think that's fine. Okay, let's see here. So and if I wanted to be fancy, so this is where some of the process subfeature status stuff comes in, right? Let me see here. So one of the fun things, right, is if we make a plane, and we sketch a point, right? Let's actually do this, right? So let's say instead of selecting here, right, and not getting our hole, right, we were to instead select this point out in space, right? So right now, because we're passing in the location, right, the whole tool highlights this location here as not producing a hole, and it complains, right? Which is not inherently wrong necessarily. But if we wanted to be fancy, which, you know me, I love, I mean, I can't get enough of this stuff, right? so we can be cool and let's pull up the args for call sub feature. Right. So we get some args. Or actually, yeah, it's process sub feature status. Right. So we can have a feature parameter map. Right, and so what this is, right, is this is a mapping of field names from the sub feature to our feature, right? So for example, in a sub feature, right, this parameter is locations, right? But actually in the parent feature, well, technically it's two different ones. So that doesn't do a ton of good. Although we could take the function and do it that way. But we would need to dynamically change based off which location. But we can do this. We can say anytime you want to highlight scope, you actually should highlight the circle edge instead. Is that even helpful? Bearing edge? I think it's called, right? And so basically then, right, so for example, right, so if I flip this the wrong way, right, so if I don't have this, right, then what happens is it says whole no hits, right, and it goes and tries to find the scope parameter to highlight, right, but obviously that doesn't exist because we don't have a scope parameter, so it doesn't, right. If we instead map it onto the bearing edge parameter, right, then what happens is it finds the bearing hole parameter, and so we end up getting this highlighted, right, which is maybe more correct. I mean, it is correct if you're doing like this, right? And I'm noticing we're not getting the whole tools, which is very sad. Since when has that been a behavior? That does it. If I have the scope. That's weird. Oh, do I need to do like... display? Is this not true by default? Aha, it's not true by default. That's crazy. Why is that not true by default? That's so goofy. Okay, whatever. Yeah, so I can propagate the error display like that, right? And that way it highlights there, which is cool. And, you know, maybe it should highlight locations as well. Well, no, it can't really. But yeah, so you can do stuff like that. And you can also map locations onto here, right? So it would highlight these guys. But the problem is there's two of them because I did it that way for reasons. So there's not a whole lot you can do about that. But yeah, so that's one way to use the whole feature. Or that's how you can kind of shoehorn the whole feature into your feature. And let's make sure this tapped is working correctly. I assume it does, but let's just make sure. Right. So if this is a tapped hole, right, uh-oh, it's not showing up as tapped, right? So we're going to want to fix that. So let's go look at the options again. Yeah, we could set our tip angle if we wanted, which is neat. We could make it flat. But it's a through haul hole, so it doesn't matter. Let's scroll back down to that. Okay, end style, start style, style. Show tap depth, has clearance. I think I can just set has clearance to has clearance. that. Did that do it? It is not happy. I'm seeing a cannot compare undefined error. So we're passing one half of the equation, it seems. Do I need thread standard.ansi? That didn't help. End clearance. Tap clearance. So like a lot of stuff here is applied by default, right? Let's try is tap through. Right. Yeah, we're definitely hitting a nerve somewhere. Because this has clearance is causing shenanigans. Let's see if is tap through does it. Nope. Not even a little bit. Okay, now we're playing guess the parameters. Show thread class. Oh. I kind of wish I could inspect that attribute again. Let's go take a look. Is it tap drill diameter? Maybe I need to be doing V2 stuff. Although V2 had a bunch of parameters that weren't set, which was not great. Oh, that's interesting. Right, so if the tap drill diameter is undefined, it just becomes the whole diameter. So you definitely have to set that it's being tapped somewhere else. And here it says tap drill diameter has to be greater than or equal to your whole diameter. I just get the transform here, that's funny. Reduce locations. Yeah, so they always get the table if it's V2. Probably. Produce holes. Show tap depth. Okay, that's not going to run. Yeah, this isn't going to run because the end style is whole style dot through. So that won't happen. So we get into produce holes. Okay, let's look at the parameters again. Show thread class. I'm like, I shouldn't have to set the whole table, right? Is the thing. Unit system. I mean, that's v2. Simple, yeah. It's already simple. Thread standard. Has clearance. Has clearance is an old parameter. Diameter. Okay, let's see. Has clearance, yes. Whole style simple. Locations, sure. Scope. I mean, we won't have a 1 for that. Show thread class. Are we expecting to have a thread class? Let's see here. Tapped. You could have a thread class, but you don't have to. Okay. Show tapped depth is interesting. Tap clearance. Hole diameter, tap drill diameter. Right, it's down here. Oh, what? It only happens if blind and last is true? Weird. Is multiple. Huh. There's tip angle style, show tapped depth. Okay, we're not V2. Yeah, so it won't be tapped through. We should have a tap clearance as well. Ugh. Show thread class. Yuck. Yuck, 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 yuck. Okay, thread standard is not what we're looking for here. Is tap through? Sure. Okay, let's just try this. This is just me fishing at this point. That gets us past that. Okay, wait, what does a number 10 hole look like? That's a good question. They have the tapping information here. Number 1024 through. That might just be a whole table thing, huh? Okay, let's try setting as V2 is true. I think I'm gonna need a standard path though, which is annoying because I don't have a standard path, obviously. if I do this, oh, now it wants a whole diameter. Meh. The hell? Okay, it wants a unit system. Maybe we can provide a unit system, that's fine. Wait, where would I go? Oh, here. ANSI whole table X. Okay. Yeah, so let's just cast it for now. Okay. Now it wants a length tolerance extended. It's saying it wants a precision, which I do not have. Okay. So I don't think isv2 is the solution here. I mean, I could make one of... Oh boy. This is not fun. Let's see here. So the problem is we need a lookup table path. Is really what this is the problem here. All right. Because clearly we need that whole. Yeah, I can't do the isv2 thing. Let's try just this, I suppose. Okay, and so now we're getting the problem of, yeah. So there's just a bug in their code where you have to have both of these, even though they're not used, and they immediately get copied. Oh, I guess you could do this, right? No. Gotta have a whole diameter. God forbid. What? Consecutive match holes must differ in their radius? Excuse me? What? Okay, so you have to do that to get... Okay. Okay. So part of me wishes I wasn't using the latest and greatest hole feature at this point, because it's clear they've got some bugs. You know, they didn't fill in all the v2 parameters when they did the cutover. So like these just have to be v1 and v2, which is incredibly goofy. So that's obviously not what you want to see, but you gotta do what you gotta do, right? So we'll provide those just to shut it up. Okay, so now let's see here. Yeah, so let's try to find this lookup table path, I guess. So I'm going to put this over here, right? Maybe this is a mistake. Probably this is a mistake, but all table fs. Sorry, this one. Okay. So I think we're looking for the ANSI EX external thread. No. Tab table? Aha. Well, that's different, but okay, we can start. Oh no. Oh goodness me. That's so cooked. Oh, I guess, okay, it's big brain time. All right, here's what we're gonna do, right? So I'm gonna select the hole I want, right? I want it tapped, I want it straight, I want it close, right? And then what I'm gonna do is we're gonna delete all this, right? Okay, so we are going to right down here, right, we can, oh, where is it? There's a way to show code. Aha. Yeah, so here's the FeatureScript code, right? And so here's our whole feature. And here is our lookup table path. Bada bing, bada bop. And it looks like it's our ANSI whole table EX, right? Okay, so this is actually, yeah, so I'm happy about this. Okay. So we'll just paste that, right? Okay. And then clearly the pitch needs to change based off of our table, right? So const table equals get whole lookup info. And this needs to be lookup info dot path dot let's take a look, right? That's gonna be threads. Wow, that's a terrible name. We'll name it pitch as well to standardize a little bit. Dot pitch. And since I can't be arsed to regenerate this, oh, it's just this. Okay, cool. All right, pitch, right? And then that colon undefined, right? Okay, so let's try that now out for size. And see how we do. Oh, is not having a good time. What? Lookup table evaluate? Hole diameter. Oh, right, because we have to edit the whole table because we changed the pitch. And so the path was wrong. And So that's just a one-time thing because we're, changing things on the fly. And, oh no, wait, hold on. No, that's so unfair. Okay, hold on, back to the drawing board, right? So, it's possible we grabbed the wrong one somehow, right? So let's show the code again. ANSI whole table EX. I mean, this does look like the right one. Could it be ANSI whole table? No. Okay, so it is ANSI whole table EX. That seems right for sure. There's a thread class in here. Let's see here. Oh, hello. Here we go. Okay, so there's a hole diameter V2 fit tolerance table. No, that's fit. We don't care about that. Tap drill diameter. There's a precision on that. Hole diameter V2 hole class tolerance bound. Oh, that's tolerance. Yep. End style. Offset. Oh, okay. Wait, here. So here's the yeah, so here's the standard tables, right? So standard tapped or clearance, right? But you can see those aren't getting used, right? That's just custom. But I do wonder if they would be getting used because it's not an isv2 feature. Right. And if I had to guess, that's what's happening, right? Because the path we've got is ostensibly for a v2 feature. So let's try that. Okay, so we're going back to the isv2. Right. Okay, and it needs a length tolerance. So we need a precision. So I assume it's all of this. Do I need that? Oh, maybe I don't. Interesting. Maybe I don't for the V2 version. That would be nice, wouldn't it? Definition field, hole diameter, tolerance type, that's this thing here. Right, and I imagine we're about to go through this again with the other type as well. But yeah, tap drill. Precision and tolerance, right? So we're just copying and pasting happily along. End style V2. Oh, whole end style V2 as well, because they forked that. Oh, hello. Okay. So that's all the preconditions. Right. Aha! Ta-da! We did it. We did it. Okay, that's exciting. That is very exciting. Yeah, so there's 24 and there's 1032. So, oh, fuck. What happened there? I changed the fastener fit from free to close. Oh, the fit changes too? Yeah, that would do it, huh? Yeah, fit. dot fit. That makes sense. Is it actually named fit in here? It is named fit. Interesting. It's saying it's not a string or value with units. For what? The fit? Oh wait, what did I do? Path.fit. That's going to be closer free. Yeah, what's wrong with that? We're so close. Oh no. It always wants it. That's not good. Oh no. Whole type, huh? Wait, hold on, let me check. It's probable I just didn't, no, that's right. Close and free, close and free. Fit, whole type. Oh wow, I actually did name that. Wow, I binked that. Okay. That's cool. ANSI whole table EX. Okay, let's just always return this, I guess. Right? And hopefully these other parameters won't get used or, you know, will get ignored properly. They are not getting ignored properly. I mean, if I'm willing to just shove these in here, right? All right, I'll grab this again. This has definitely gotten a little out of hand, I think is fair to say. Oh no. Oh, come on. Really? Gotta quote them. Okay, let's try that. Oopsies. Wait. What? What did I do? Oh, I got two clearance whole tables. Okay. All right, that looks correct. And so now that we've done that, in theory, this is the same So in theory, these are both just the same, like, because all the keys and values and the paths are the same, right? Oh, I guess not in the path, because the path has extra, because that's the value, not the path. Because we're keying into their table now is the trick. Well, let's just give it a shot, I guess. Yeah, so it's confused now because it doesn't know about that. So this doesn't work, basically, is the takeaway. Here we need to use the string literal because type is a reserved keyword. And this needs to be a var. Okay, and so we'll just inject it here directly. Okay, and we'll update this once again. Hum-da-dum-da-dum. It is late and I should probably go to bed, but here we are. Hard at work. Okay. All right, let's see what's missing. So, okay, so our lookup table path for ANSI whole table EX is fit. Yeah, we got that. Size we added. Whole tag. Oh, we don't have size when we are like that. Okay, so we always need to add size. Okay. So we do that, and now what? Ugh. Wait, is that ANSI whole table? ANSI whole table EX is still untapped. What happens if I change this to clearance? Oh, it's cool they have the mapping set up. Well, more or less. Let's see what we got here. ANSI whole table. So I wonder if it's using the ANSI whole table here. I guess it doesn't really matter because it's the default, right? So we don't really, it doesn't really matter if we have our path question mark undefined, right? Although I guess if it's demanding it, then you gotta do what you gotta do. Let's check the call. Yeah, too far. Is lookup table violated? Why is this getting called? Why do you care? What the heck? Oh my goodness. Oh my goodness. Is it checking every key under the sun? I mean, we know it made, okay, so we know this works, right? Because it cut that fine. And at one point this did work, but now it doesn't. Which is the part that I don't 100% get. That looks right. Hell. Let's take a look. Let's take a look. Okay. ANSI whole table, EX. Fit close, whole type tapped. Fit close, whole type tapped. Pitch 32 TPI UNF or 24 TPI UNC, size number 10. Type straight tap. So that is the same path, right? And then this is a different table entirely. Is it defaulting to ISO or something? I should have just copy pasted the attribute. Oh man. Yeah, we would not be doing this right now if we had just copy pasted it. Is the funny part. No, it shouldn't be some other parameter, because it worked, right? We saw it worked, and it was beautiful. Size number 10, type straight tap. Pitch 24 TPI. What did I do? TPI UNF. Did I mistype it somehow? 24 TPI UNC. Let's see what a 24 hole looks like. I mean, And that is the spitting image, right? Fit close, hole type tapped, pitch 24 TPI, space UNC, size number 10, type straight tap. This is kind of cooked, not gonna lie. Lookup table get value is failing. Not saying the value the lookup table is pointing to is wrong, which is very surprising. Unless it's trying to get another table we're not looking, or we're not passing. Which is possible. Yeah, so that's my current theory. Okay, let's copy the rest of this stuff, I guess. The nice thing is it's all valid code. So we can just copy paste away. God, this is so much code. Okay. So here's the these are the old V1 table paths. Right, so we'll try those as well. Standard blind and last. And ANSI thread class. I guess we'll also try. That works. Right, let's go look at the whole feature again. Okay, let's see here. So the parameters that are set by default, thread standard, hull standard, none of them. So that's a bunch of V1 defaults. Oh, there is an upgrade task. That's interesting. Okay, so this works. I'm confused because there was that one brief, beautiful moment where it worked, and then it just stopped, and then it hasn't worked since. Because like the TPI was right and stuff. And this is just a naive constructor, right? That's not doing anything. I hope. Yeah, it's just cast it. It's as simple as it gets. Let's copy this guy again. Turn to our roots. It's possible I'm not passing something correctly for some dumb reason. Okay, what does this do? Okay, let's try grabbing all of the whole tables. ANSI whole table, ISO whole table. Right. Oh, I did see an ANSI thread class V2, which does have me nervous. Nothing. Ugh. Yuck. What is this error I'm failing? Ugh. Ah, boy. Is standard violated? Is a lookup table violated? Get standard table. Get active lookup table. Get active lookup table. ANSI whole table EX. Right, and that's a hard-coded table, so that's always going to work. And then okay, there's the active table, and then the path is, they call the table for some dumb reason. Yeah, so definition is V2 is true, and the unit system is inch. Right, so it is going to be grabbing that and that. ANSI whole table EX is the problem, is what that's saying. Let's try this. type straight tap. I don't know what the hell is happening. Is this just a problem with the static analyzer? No, we're not monitoring anything. Right? I'm grasping at straws here. I might have to call it. I probably should have called it a while ago. And revisit this tomorrow. Because it is late and I am tired. Look up table get value. Okay. So inside here, inside lookup table get value, definition entry dot key. Wait, what? I'm sorry, what? Definition entry dot key. What is entry? For our entry in table? Okay, definition is just the top level definition map. Which is fun. Okay, so the standard table, right? That's going to be your ANSI X12, right? Wait. Result.standard. Result.table. You always get a table. And this is going to be your ANSI, your ANSI whole table EX and your ANSI / your ANSI whole table. Okay. And it's returning the value. So we should go look at that value, I guess. I think what's happening, right? So my current theory is oh boy. Yeah, so my current theory is ANSI whole, oh shoot. It's named something differently. Who does this? EX. Okay, so it's ANSI whole table EX. Okay, so we're looking at the tap table. We're looking at the V2 tapped table. Okay. We're looking at number 10. We're looking at 32. So it expects tap drill diameter, hole diameter. Is the problem we're not setting hole diameter and tap drill diameter? I will cry. Hole diameter, tap drill diameter. Okay, what else we got in here? Lookup table get value. Right, so my theories is looping through these, right, and making sure they're all correct, right? So if any of them are not specified, right, like the parameters, then you have a problem. So let's just make sure we have them all, I guess. What a mess. Oh, we got a new error. And it's not a length, which makes sense. That was it. Okay. And there it is. Okay. Now it's complaining about fastener fit. Right, because this is technically a fastener fit.none. Okay, so you definitely don't need these. Okay, now we can go through and clean some stuff up, which is nice. I don't think you need this, period. Okay, ANSI whole table X in here twice because I was so desperate. Isn't it fastener fit.none and then you're just, wait. What? Wait, how do you prevent that error? That's a good question. None? Wait, but that's your whole diameter. Oh, but it becomes your tap diameter? Oh boy. Wait, so you have to do a tap diameter and then you don't specify? Oh god. Wait, so this is actually going to be false, right? And then the way you specified is to there? Is that how this works? And now it's saying we've overridden parameters. This is so stupid. I'm not happy. Okay, I don't think we need those. Yeah. And we shouldn't need these. Those are required. Okay. All because we didn't have a major diameter, really? Is that really the problem here? Yes. So we don't have a major diameter. No. What? How did I fix this problem? Was it the whole diameter and tap drill diameter then that did it? Okay. how it's saying parameters are overridden. Is that my code saying parameters are overridden? I hope not. Wow. So the whole diameter is the problem all along. Wow, okay. Something about that close fit. Really makes that required for no reason. Let's see, so this is the hard-coded ANSI whole table path. Yeah, okay. Jesus, okay. Path that size and type. Yeah, because we have fit, whole type, and size. Or we have whole type, pitch, and size. So we need fit and type. Or size and type, yeah. That's right. Okay, so it's saying parameters have been overridden, right? I'm not sure what that's all about. Let's check the clearance mode. Close. 201. Does it actually do that for me? No. Free one. It's also not respecting it right now, which is funny. And not what I was expecting. Oh boy. I should really just be using the whole feature for both if I'm gonna do this. Like in for a penny, in for a pound, right? Well, not even that. Like if I'm gonna use the whole feature, I should just use it. Fit, size, whole type. What's the difference between the ANSI table and the ANSI table EX? Oh, one's for counterbores and countersinks. So it's always going to be EX, basically. Okay. Okay. It does not care about that. Why would it have a clearance? It doesn't have a clearance. Bloody hell. Okay, we shouldn't need an ANSI whole table. Ever. Wait, is this, what is this? What is that? What? Oh boy. Oh boy. Why do I not have... Where is my heckin'... Why is this not working now? Like, what? That works. Why can't I override it or anything? Okay. Full diameter V2. That's always hidden. What the heck? What the heck is major diameter even? Like, what is this? Is there some hidden parameter the table sets that, like... Is that what's happening here? There's hidden parameters the table is setting, and if you don't set those, then it's just cooked and it can't, close and free doesn't work either. Well, how does that work? And tapped. doesn't matter. That's right. Okay, so when it's tapped, so we still do use tap drill diameter. And then has clearance is false. Nominally, or fastener fit is none. Alright, this is so bad. I'm totally just crashing out right now. Okay, that works. And then this doesn't actually affect anything. Wait, so why do we have it then? What's the point? Oh, because that's for the hole. Oh my god. Oh, okay, so that affects the 10, but not this. Okay, that makes sense. Yeah, because that, okay. Oh, God. Oh, goodness me. Oh, goodness gracious. Okay, yep. So that's fine. So this is never going to change unless you change this. Oh, well, that's awkward. So theoretically, I don't need a hole diameter here. Or like... Why don't you work? 1.7. Well, you're creating... What? What the frick? Okay, that's not being used. If I make you clearance... Okay, why isn't this working? What the hell? Like, what is happening that's causing the hole size to not get updated? Right, that's the crazy part. That the hole size isn't along for the ride. Because, like, normally you just, like, the hole size goes up and the hole goes... You get a bigger hole. I don't know. Show tap depth. I assume there's some value the lookup table is setting that's causing problems. I mean, has clearance is false. Right, hole diameter V2. What happens when I change this to like 0.2? Okay, that updates hole diameter V2. Oh, hole diameter. Okay. Interesting. That doesn't have an expression, that just gets it, but... Precision, limits, fit tolerance. Yeah, there's hole diameter. C-bore, C-sink, tap drill diameter. Oh boy, major diameter is still 0.19. And there's all the default values. Wow, 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 wow. I don't understand how... Oh, wait, hold on a second. Am I stupid? I might be stupid. Definition of hole diameter. What? What? Okay. What? Why isn't that working? Oh no. No. Ugh, why? Why did I do that? Why am I setting the values? What was I supposed to be doing there? Oh. Yeah, I'm supposed to be doing this in response to the lookup table changing. God damn it. Okay. So I was doing this always, right? So even when you change the whole diameter, it would reset it. So this was wrong. I need to compare. I probably need to get the active table and then compare that or something. Let's see. Yeah, if get active table does not equal active table. And here the active table is the active parameter. There's the active whole path. Wait, let's see. So, yeah. Wow. Ouch. Ouch, ouch, ouch. Ouch, ouch, ouch. Definition of whole path. Wow. Okay, that hurts. That hurts a little bit for sure. Okay. So now that you can actually change the values. I should have realized when the frickin'. Okay. 0.201 was enough to break that apparently. For some reason. Okay, that should do it. Yeah, so you can tap it. And it's funny, we are getting parameters has been overridden from the, yeah, from the parent feature as well, because that is a feature status. So I technically don't even need these. I can just frickin' return that. So this is gonna need a cleanup pass. Definitely. I think at this point I just need to bite the bullet and send the whole through both. Would make it a lot more consistent. Because that's where we're getting some of these issues. That being said, we're very close. Let's see here, 0.17. Okay, yes, that's updating that now. So it's using the whole diameter there, which is wrong. Why is it using the whole diameter? Is that just the behavior? It might just be the behavior. If so, we can fix that really fast. Oh yeah, it's just not. Okay, that's funny. I don't know if I need this then at all. Interesting. So there's no override error there. Is there an override error here now? 0.2. Wait, why is there an override error there but not there? What? Oh, because this isn't being used. No, this is a whole tool though. I mean, this isn't a whole tool here, so sure, you get whatever. What is this error? Cool. That's very helpful. Thank you, whole tool. My sketch is too big, of course, but... Or my bearing hole. No, my bearing hole's the right size. My bore hole is not. I didn't like how there was no error display there. That wasn't great. Okay, that works. Yeah, that all works there. Even this works, right? 0.3? Oh, it doesn't work. Interesting. Wait, what? Okay, but what if I disable... that? Right, well then we're not using the whole tool at all. So that makes sense. Right, here we are using the whole tool though. Right, that's the weird part. Right, because it should be saying, you know, so it's weird that it does it sometimes. Although it is interesting how it's consistently for whole diameter. So maybe we need this just for that. I don't know. Okay, it's definitely past my bedtime. This has definitely been incredibly cooked. We can do that ourselves. Okay. Alright, so I have a bug to troubleshoot there. Obviously this entire thing just needs a massive code quality pass as well. Tomorrow I'll probably just set it so we always use the whole tool for everything. That should clean up this logic a lot. I don't know if I'm gonna edit this video too. I probably should because it's so long. But I don't know. Anyway, it's bedtime. It has been fun. I don't know. But yeah, I mean, this works now, which is pretty neat. So you can, make your bearing hat, connect your mounting locations if you want. And, yeah, you can not cut your mounting holes, and now you can also do your fastener fits. So there you have it. Was it worth it? I don't know, but you can do it now. So, and I did learn a lot about the hole tool. So, yeah, the new V2 hole tool is definitely cooked a little bit for sure. That was definitely not great, but yeah. All right. Hopefully this was helpful. I'll talk to you guys later.